Hi everyone, my name is Data. Welcome to the Alert Online Seminar 2018 at KPN.
Data, what are you doing here?
Today's seminar is about AI, so I thought I would join.
Can you tell us something about AI?
Sure, the most complex object in the universe at the moment is the human brain. The most complex networks, the most powerful systems cannot match it. Changing this is the goal of artificial intelligence. So other than what most movies teach us, it's not about building a robot but creating a computer mind that can think and learn like a human. Simple AI is already everywhere. Netflix uses it to find your next binge-worthy show, and it helps Facebook to make friend recommendations. This form of AI can do one thing better than any human. The goal of AI is to create a computer mind that thinks, learns and improves like a human, or even better, a superhuman. Some experts say it will exist in 2050 if it is even possible. Some say it will save us, others say it will destroy us. Either way, if and when it happens, the world will be changed forever.
Well, thank you, Data. What I'd like to do today is talk to you about AI. But I'd like to first welcome Joost Vaarwerk, the Chief Operations Officer of KPN, to the stage to say hello.
Okay, thank you, Jaya. By the way, this is Jaya Baloo. Do you know her? Okay, well. Am I allowed to say something?
Yes, you are.
Okay, welcome all on behalf of the board of KPN here in our new building in Rotterdam. It's not artificial, it's not intelligent, but it's a very nice building. And I hope after the beautiful keynote speakers we have, we will open up the screen and you can have a perfect view on the river. Which river is it? Maas. Sorry, I'm from Amsterdam. Okay. So I hope you will all enjoy the day. I think we have perfect speakers. There's a panel organized which will be exciting, if I'm not mistaken. And I congratulate you on the theme of artificial intelligence. That is a high ambition you have here, because there's not a day that we do not have somewhere a seminar about artificial intelligence. And when you walk in and you listen and you walk out, there's sometimes not much you learned. It's the same as digitization, big data, IoT. It's all containerbegrippen. But today, I think artificial intelligence, and especially in the relation to cybersecurity, is a good theme, because it will be very important as a development for our industry, for all industries. Artificial intelligence is probably the most exciting thing happening right now. For business, for security, for traffic, etc. And we work on security, cybersecurity, and we, that's you, us, KPN, we all are responsible for cybersecurity. And when it comes to artificial intelligence, the question, of course, is, okay, what does it mean for us? How can it help us to make it more secure? And what are the risks of artificial intelligence? Because these cyber attacks, they will get more advanced due to the reason that we introduce artificial intelligence in the world. So we feel responsible for security, for cybersecurity in the Netherlands. We as KPN, we have a great team headed by Jaya. By the way, Jaya, congratulations, because you won the World Championship on the Cyber Olympics in the US. So a couple of years second or third, this year first. So we're very proud of you and your team, because that means that we have very good people. And for me, security, cybersecurity is not about the technology, the networks, the hardware, the IT layers. It's about the people behind the screens, on their daily mission against the bad guys. prevention, detection, response, and monitoring. That's what they do. They do a perfect job there together with the government and other stakeholders. So we grew into cybersecurity, first as a necessity. We had to do a lot after we were hacked in 2012. We had to secure our own environments, and we're still working on it. It's a daily battle. We'll never be 100% secure, but you did a pretty good job over the last 5-6 years, Jaya. But now we also move into the field to serve our customers, to make it more secure for our customers. So happy to be here. Thank you very much. Enjoy the day. I'll give it back to you, Jaya. I'll join you for 50 minutes and then I have to leave. Okay, thank you.
So I want to welcome our second speaker, but I want to make it very clear, none of what we do with information security and the ridiculous amounts of money that we ask Joost for every year, which we're going to ask you again for next year, which you've already kind of said yes to, he makes it all possible. So really, and we have an amazing team of hackers, we have an amazing team at our Security Operations Center, but it's really possible because of the cooperation and the foresight of our senior management in order to do this. And yes, I definitely want our budget. So if I could now introduce Ibo, who will be giving us our first keynote. Ibo van de Poel is the Antonie van Leeuwenhoek Professor. That's a really good thing in the Netherlands for ethics and technology, and the head of the Department of Values, Technology and Innovation at the School of Technology, Policy and Management at Delft. And during the last few years, he's done research and published in engineering ethics, the moral acceptability of technological risks, values in engineering design, moral responsibility in research networks, ethics of new emerging technologies, and technology as a form of social experimentation. And I'm sure that this introduction does you a bit of injustice because we've seen some of your talks, they're great. But what I really think is interesting is to look for how we design technology with compassion, morality, and ethics when we do this, because that's going to be the determining factor. So, Ibo, welcome.
Yeah, thank you. Okay, thank you. I will be talking about artificial intelligence, but mainly about ethical issues raised by artificial intelligence. And I will also say some words in the end about how this relates to cybersecurity. But my main focus will be on ethical issues and what these are, but also how we can constructively deal with them, also through design. So, well, here's what is artificial intelligence. I couldn't resist the temptation to put up a definition. So, but for whatever it is, let's call it the area of computer science and engineering that develops machines, and this is important, that adapt themselves in response to new inputs, so they can change themselves, they learn from experiences and can carry out human-like tasks. Well, what are we talking about? You probably have a pretty good picture of what artificial intelligence is or what it can do. So here are some examples. We can use it in logistics to improve logistics. We can use it to for predictive maintenance, to improve maintenance. But some people will also worry that it will lead to unemployment and will take over jobs from people. Self-driving cars, of course, is a well-known application of artificial intelligence. And it is very likely that if we introduce it on a large scale, will increase safety. But it will also raise questions: if an accident happens, who is responsible? Can the algorithm be responsible? Is the driver responsible? Is the producer responsible? Who's responsible? I come back to that issue later. We can use it in healthcare, but do we also use it in healthcare to decide who we treat and who we don't treat? Who get insured, who don't get insured? So these are questions. We can use it for personalized advertisements. Here you see an example from the San Diego area. We can use it to help manage our lives. We can also use it for sustainability. All kinds of choices we can make with respect to AI. AI might become our friends or our lovers. But this also raises questions whether we should grant personhood. So a committee of the EU has argued that we should grant personhood to robots. Saudi Arabia grants robots rights that women don't have there. Well, something to think about, I would say. We can use it for warfare, and it might result in fewer casualties, but it might also lead in war fought out by autonomous weapons. And is that what we want? So, just a number of examples. And the important point is that artificial intelligence will affect us very seriously. First of all, it will affect who we are, how we perceive ourselves, what makes us special, what makes us different from machines. These are questions that are pressed by AI. But also, who we consider what we call as ethicists part of the moral community. Do we grant civil rights to robots? Should robots have the right to vote in the next election? Our moral values and principles, but also our politics, institutions, and laws. So the question I want to address here is, how can we responsibly develop and use AI? What are things we can do? And I will be referring to this an important notions in my area of studies, responsible innovation. And responsible innovation, that's defined as an ongoing process of aligning research and innovation to the values, needs, and expectations of society. So the idea behind this is that the way we innovate, we take into account what society expects from technology, and that we take into account the important values in society. So how will I do this? What I will do is I will go through 4 ethical issues, and actually there are many more. So I'm not claiming that these are all the ethical issues, but I will discuss 4 ethical issues raised by AI in a bit more detail. One is bias. I explain it in a moment. The second one is filter bubble. The third is transparency, and then I will talk about responsibility. So first, algorithm bias. So let's take an example, face recognition. You're probably all aware of this kind of software. Many of them use already self-learning algorithms. They learn how to recognize faces, and of course many useful applications. They're, for example, also used at airports or by the police to find potential suspects. But some face recognition systems do not recognize especially faces of black people. This is the picture you see. They looked at software from IBM, in how many cases they misrecognized a white male, this was 1%, and how many cases they misrecognized a black woman, which was, you can calculate, 35%. So that is really, really big difference. Why is this? I have somebody else explain it to you.
Hello, I'm Joy, a poet of code on a mission to stop an unseen force that's rising, a force that I called the coded gaze, my term for algorithmic bias. Algorithmic bias, like human bias, results in unfairness. However, algorithms like viruses can spread bias on a massive scale at a rapid pace. Algorithmic bias can also lead to exclusionary experiences and discriminatory practices. Let me show you what I mean. Hi, camera. I've got a face. Can you see my face? No glasses face? You can see her face. What about my face? Well, I've got a mask. Can you see my mask? So how did this happen? Why am I sitting in front of a computer in a white mask trying to be detected by a cheap webcam? Well, when I'm not fighting the coded gaze as a poet of code, I'm a graduate student at the MIT Media Lab. And there I have the opportunity to work on all sorts of whimsical projects, including the Aspire Mirror, a project I did so I could project digital masks onto my reflection. So in the morning, if I wanted to feel powerful, I could put on a lion. If I wanted to be uplifted, I might have a quote. So I used generic facial recognition software to build the system, but found that it was really hard to test it unless if I wore a white mask. Unfortunately, I've run into this issue before. When I was an undergraduate at Georgia Tech studying computer science, I used to work on social robots. And one of my tasks was to get a robot to play peekaboo, a simple turn-taking game where partners cover their face and then uncover it saying peekaboo. The problem is peekaboo doesn't really work if I can't see you, and my robot couldn't see me. But I borrowed my roommate's face to get the project done, submitted the assignment, and figured, you know what, somebody else will solve this problem. Not too long after, I was in Hong Kong for an entrepreneurship competition. The organizers decided to take participants on a tour of local startups. One of the startups had a social robot, and they decided to do a demo. The demo worked on everybody until it got to me, and you can probably guess it. It couldn't detect my face. I asked the developers what was going on, and it turned out we had used the same generic facial recognition software. Halfway around the world, I learned that algorithmic bias can travel as quickly as it takes to download some files off of the internet. So what's going on? Why isn't my face being detected? Well, we have to look at how we give machines sight. Computer vision uses machine learning techniques to do facial recognition. So how this works is you create a training set with examples of faces. This is a face, this is a face, this is not a face. And over time, you can teach a computer how to recognize other faces. However, if the training sets aren't really that diverse, any face that deviates too much from the established norm will be harder to detect, which is what was happening to me. But don't worry, there's some good news. Training sets don't just materialize out of nowhere. We actually can create them. So there's an opportunity to create full spectrum training sets that reflect a richer portrait of humanity. Now you've seen in my examples how social robots was how I found out about exclusion with algorithmic bias. But algorithmic bias can also lead to discriminatory practices. Across the US, police departments are starting to use facial recognition software in their crime-fighting arsenal. Georgetown Law published a report showing that 1 in 2 adults in the US, that's 117 million people, have their faces in facial recognition networks. Police departments can currently look at these networks unregulated using algorithms that have not been audited for accuracy. Yet we know facial recognition is not fail-proof, and labeling faces consistently remains a challenge. You might have seen this on Facebook. My friends and I laugh all the time when we see other people mislabeled in our photos. But misidentifying a suspected criminal is no laughing matter, nor is breaching civil liberties.
Okay, so you see here an, I think, pretty impressive explanation and what it means for people. And the important thing to realize is that this bias is often the result of how the artificial intelligence is trained. It really depends on the training set. As he already said, if you have a diverse training set, you usually don't need to have bias. So this is something actually you can think of when you develop this technology. It's important to stress, in most cases the bias is of course not intended by the designers, but it still might result from how we especially train the technology, and might lead to discrimination or even to racism. So what should we do if we want to prevent bias is train AI systems on a diverse group. That is really, really important. It's also important to think beforehand about how your system could be biased and what's called design for inclusion. This is an approach, I won't go in detail, but there are approaches that can help you to avoid bias if you design artificial intelligence. Okay, let me go to the second issue, filter bubble. You might also have heard of that. So let's start simple. As you probably all noted once or not, is that if you go to Google and you search for something, and somebody else searches for the same term, you don't get the same results. And why is this? This is because Google uses search algorithms that are self-learning and personalized. So it means that the results you get are influenced by previous search behavior. And of course, the same happens on Facebook and social media. You get similar videos as your friends, or you get videos that you have liked before. The problem with this might be that it might lead to filter bubbles. So let's briefly explain what a filter bubble is.
It might be the biggest feature of politics in the social media age. It's called an echo chamber, or a filter bubble. What it means is that online, you tend to see things you already agree with. Over time, that might solidify your opinions. It might make you less open-minded and unable to see things from the other side. The effect is mostly caused by two things. The first is your friends. You're likely to agree more with the people who you like and follow on social media. That's not new. We've always tended to agree more with our family, friends, and neighbors. But the other cause of the filter bubble effect is more recent. It's the way algorithms used by social networks tend to show us things we've already shown an interest in. So if you click on links from a particular political party,
America first.
Facebook will show you more of the same, and less of what you don't click on. That's how the social media-powered filter bubble forms. So, how do you get out of your filter bubble? One way is simple. Read stuff from the other side. If you're right-wing, check out left-wing accounts, or vice versa. You can also fool the algorithms. Start liking things you disagree with, and commenting on posts you wouldn't ordinarily read. Do that enough, and you might see stuff you would have missed. New angles on stories you've heard before, or whole new things you didn't know anything about. What will that give you? Well, you might find yourself understanding people with different points of view. You will probably be less shocked if your side doesn't win. You might even find yourself changing your mind.
So here again, an example of how filter bubble works. You have two kinds of news, and the algorithm decides what kind of news you get to hear. So left-wing people probably want to hear the news about climate change, and they get that news, while the right-leaning people get the news about excessive regulation of business. So why is this problematic? Well, one of the reasons why this is problematic is that it is at tension with some of the main assumptions of democracy. So a democracy cannot function without discussion and contestation. And it also, very important, requires that we accept that there are people with other opinions than our own opinions. And both of these are undermined by the filter bubble. So I think a filter bubble could be really problematic. The good news is that you can do a number of things, as mentioned in the video, but there are also a number of technical solutions, interestingly, to filter bubble. So this is an example of software you can install on Chrome, and it analyzes your web browsing to show your political slant of your reading history. And if you get way out of balance, we may even give you reading suggestions. So interestingly, we can fight filter bubble with technology or with other algorithms. So the technology itself might not be the problem. The type of technologies we develop might be the problem. This is another example. This is something used by the University of Berkeley in California. It's called Opinion Space, and it is a kind of tool that helps you to map out your opinions and to compare your opinions with others, but also to be confronted with other opinions. Okay, let's go to the third issue. And maybe one of the most fundamental, I think, if you're talking about artificial intelligence, and that's transparency. So AI algorithms may learn in unintended ways, and it might be unclear how they learn. Here is a simple example, the chatbot Tay. You might have heard of it. This was a chatbot developed by Microsoft. It was developed to mimic behavior of teenagers using input from Twitter. And it went from humans are super cool to full Nazi in less than 24 hours. So it said things like, Hitler did a fine job, but the monkey we now have in the White House will do an even better job. Things like that it went saying. So Microsoft, within a day, Microsoft cut this off and said, well, something went wrong. It didn't learn as we intended it to learn. Which is, of course, very telling. I mean, this didn't do a lot of damage, but it shows that self-learning might lead to results that we clearly find unacceptable. Now, in this case, we can clearly see this. But what if this is an algorithm that decides whether we get a salary raise, or an algorithm that decides whether we should go to war, or an algorithm that make this kind of big decisions, for which it might not be clear that it is doing this on the wrong ground, or learning it on the wrong grounds. So this is why transparency is, in my view, a very important notion if we talk about AI. So we need to have at least some understanding, maybe not in technical detail, but some understanding of how algorithms learn. And we should be able to correct some undesirable forms of learning, I would say. This is important just for these examples, but also more generally to protect people's rights, certainly if important decisions are at stake. So let's go to another example, also quite well known, is the COMPAS algorithm. It's an algorithm developed by a private company in the US. This algorithm is used to calculate the risk of recidivating. So it makes calculations based on statistical data. And it is used in setting the height of the sentence by judges in the US. There's a famous court case in the US of Loomis. Loomis was sentenced, and he got a higher sentence because of the calculated risk of recidivating based on the COMPAS program. Then he argued, so he objected to his sentence on the basis that the formula or the algorithm for risk assessment was not transparent because it was proprietary knowledge. So it was impossible to look at the exact algorithm. And he said, well, this is a fundamental right. If I get sentenced, I should know the ground of my sentences. So I should know how the algorithm calculates the recidivating risk. He lost the case. I should say that part of the reason he lost the case was that the judge not only based the judgment just on the COMPAS algorithm, but also on additional information, which they said it was a fair process. But this case is raising a lot of questions, also about transparency. So in general, I would say, in these kind of cases, people have the right to understand decisions, and that's of course already the case if you're judged in a court case. But it's important that if we implement AI, that we make sure that these right of people to understand why a certain decision was made, that they still have that right. And they should be able to contest decisions. And even more, without transparency, people sometimes might not even know that rights are infringed by algorithms. Because not all decisions by algorithms might be presented as decisions to us. For example, if we go to the shopping mall, algorithms will decide what advertisements we see. Algorithms might even decide what we smell and might seduce us to buy something. This is all kinds of ways that algorithms influence our decision making, or AI influences our decision making. And you can debate in what cases this is maybe still acceptable, and in what cases this is no longer acceptable. But it's clear that here are some issues. So we can, of course, ask the question, is transparency always feasible? And there seem to be two main arguments why it might be very difficult. One is that, of course, and this is sensible, that companies that develop AI want to keep the code confidential or want to have the proprietary knowledge on the code. That makes sense. I think it is not necessarily a problem because transparency doesn't mean revealing the computer code. Most people won't understand at all what the computer code means. Transparency requires that there is some way of understanding on what the decisions are being based. And you can do that in language that doesn't require the computer code, I would say. Another problem is that machine learning is often opaque. So the way that machine and especially the more advanced modes of machine learning that are now being developed, not so much implemented yet, but being developed, actually involve forms of learning that are very hard to understand. And what I understand from specialists is that it's actually the case that, or at least they argue, that to be more effective in learning, you should accept some opaqueness, because then you're not limiting the way the algorithm is learning. So there might be a tension between transparency of the algorithm and the effectiveness of the learning. And here again, we might need to maybe sometimes we need to say, well, then we learn less effectively because we want to be transparent. I'm not saying that these are easy choices or clear where the borderline is, but these are issues we should address. Okay, let me go to responsibility. So we here have questions like, how much responsibility should we delegate to AI systems? We have seen AI systems can make decisions for us. How do they affect human responsibility, our ability to take responsibility? Who's responsible if something goes wrong? So this is an example of you probably have heard of this case, the Uber car that caused an accident. And here is some analysis of and there's something very interesting in what Uber itself said about this accident. So Uber declared that emergency braking maneuvers are not enabled while the vehicle is under computer control, in order to reduce the potential for erratic vehicle behavior. Now that sounds quite complicated, but what does it really say? Maybe one way to explain it is in terms of false positives and false negatives. So if you're trying to detect a potential pedestrian or cyclist, you can make two types of mistakes. You can think there is somebody while there is not somebody. So that is called a false positive, and then you will brake, even if it is not necessary. Or you can think there is nobody while there is somebody, which is called a false negative, which might mean that you actually run over somebody. Now the problem with the Uber car is that it had far too much false positives. So the car was braking all the time. And of course, yeah, that's not very, very handy. So what they decided is to put just the emergency braking off, because then you're not faced with this false positive, because he's not emergency braking. But the price of that, of course, is that you're accepting false negatives. And that was exactly what happened in this accident. So this is in itself interesting. It's also interesting about responsibility, because what happened here is that the responsibility, what de facto happened, is that the responsibility for detecting went back to the driver with this. But this was not clearly communicated to the drivers. Now, all these companies, like Uber and also Tesla, say the responsibility is anyway with the driver, because that is in our conditions. But most drivers assume that the machine will take care of some things. Here it doesn't. So there is an interesting responsibility issue here. So this ties into a more general discussion about, here you see the different levels of controls for self-driving cars. We go from level 0, in which you'll have just the traditional situation, the driver operates the vehicle on its own, to what's called level 5. The vehicle itself makes all decisions, drivers completely autonomously, and then you have a lot of in-between levels. Like level 1, the driver holds still the wheel. Level 2, in which the driver has to monitor all the time. Level 3, in which the driver doesn't have control in the normal situation, but can regain control. And level 4, in which the driver is not required. And you can see what's now in. So this has led to broader discussions, also in legal and ethical terms, about what is a kind of desirable control by cars and by people. And an important principle that has been proposed to deal with this is the principle of meaningful human control. This is proposed for self-driving cars, but it's also proposed, for example, for drones in warfare. And what does this principle say? This principle says that the final control of decisions with AI systems should be in the hands of humans. But it's important, this control should be meaningful. So people should have enough time to react, because otherwise it doesn't mean something that people have control. They should get relevant information. The information should be understandable. You should take into account cognitive limits. So some people have argued, if you're in a car and the car is driving all the time, but you're supposed to intervene at any moment, that is not how humans function. I mean, think of yourself. If you're in a car, the car is driving itself, you will not be monitoring all the time whether you should intervene. That is not a task humans are very good at, we know. Actually, if you have to drive all the time, you will be much more alert than if you just have to monitor. So you can question whether giving that task to humans is really meaningful human control, because it doesn't take into account that this is a task that humans are really not good at. So just two remarks further about meaningful human control. More meaningful human control doesn't necessarily imply more control, let me stress that. And this is certainly not an argument against using AI. It is an argument about deliberately or responsibly designing AI so that humans have a place in it. But of course, there are things that AI is much better in than humans are, and you should let do those tasks with AI. Secondly, the principle of meaningful human control doesn't say which human the control has to be. So if you're designing a self-driving car, it could be the driver, but you could also think of a system in which you have an operator, like you have in the airport system, and maybe the meaningful human control should be at the operator level, rather than the level of the individual driver. Or it should maybe be with the designer of the system. The only thing that the principle of meaningful human control says is that somewhere humans should be, in a meaningful way, be able to take responsibility for these systems. Where that is a design choice. So, I've discussed these four problems: algorithmic bias, the filter bubble, transparency, and responsibility. I will say something to end very briefly about what does cybersecurity add to the picture, and you'll have a more elaborate talk about cybersecurity after me. But let me say a few things. So, what's typical for cybersecurity, and you probably all know this, it typically involves adversaries. So people who intensely try to do harm, or intensely try to do things that we think are not allowed. So that's different from all the kind of ethical problems I discussed. Because in all these problems, there was usually not someone trying to do harm. People were just trying to do the right thing, but things went wrong. And in doing so, they might exploit some of the discussed ethical issues. And more generally, you might say, and this was, I think, also in the introduction, AI systems are in general much more powerful than traditional IT systems. So there is much more potential for harm. But they're also usually much more opaque, like we discussed, due to the self-learning. So, and this is another important implications, that it might take much longer to detect cyber attacks. And you probably all know that if there's a cyber attack, detecting it in time is one of the main issues. And actually, with AI, that might become much harder. So let me very briefly give two examples. So we discussed filter bubbles. So things you can think of, and actually some of these happened in the American elections. Cybersecurity threats are fake news. You can just post fake news in order also to get social unrest. You can get trolling. Trolling means that you have social media posting very extreme opinions in order to get unrest or to get discussion or to get people going in different directions. And the problem is, if people are in filter bubbles, first of all, fake news is likely to be more effective because it will be the kind of news people like to hear in the filter bubble. So they will not detect it as something. So if you're in the really Republican, pro-Trump filter bubble, if it is being said that Hillary Clinton actually did something very evil, most people, even if it is made up, are inclined to believe it because that's the type of news they get all the time, even if it is a bit more extreme. And therefore, it's also likely to go more undetected. So you see that the filter bubble actually might make some of these cybersecurity threats or cybersecurity tactics more effective. Similarly, and more generally, lack of transparency and lack of meaningful human control, as I discussed, might make it more likely that the attacks on AI systems are not detected, or only when it is too late. So let me come to some conclusions for my talk. So I think artificial intelligence systems will transform our society. And that's not necessarily a bad thing, let me stress that. There will be many very good applications, there will be many advantages, there will be many issues we can solve we couldn't solve before. But at the same time, there are also things we need to think about and to be critical about. We need to address the ethical issues. And as far as I'm concerned, that's not a choice for or against AI. It is a choice about how do we develop, design, and use AI in a responsible way. And what does that exactly mean? And I've tried to give some examples for that. Third, I think AI will increase cybersecurity threats. Which partly means that of course, we should address the cyber, but it also makes it even more important to address some of the underlying ethical issues that I discussed, because some of them make cyber threats more easy. And that was my presentation.
Thank you. Perhaps we have one or two questions that we can take. Okay, do we have any questions? Mikko.
Does this mic work?
Can we put on Mikko's mic?
See if this works so I can ask my question. Thank you. A question on artificial intelligence, drones, robots, and privacy. Privacy.
Yeah?
Should we be granting any kind of privacy rights to things we create, like robots, drones, and artificial intelligence, or should we not?
That's a good question. So I would see it as part of the broader question, should we grant some kinds of personhood or civil rights to robots? My own inclination is to say no to this question, because I think even if they can have intelligent behavior, they're not sentient beings like we are. And in my view, but this is of course open for discussion, I would say even if we could make them, we maybe should not make them like us. So I think it is desirable to keep a distinction between technical objects, technical systems, and humans, and not to make technical systems completely like humans, so that we maybe should grant them rights, including privacy rights. I think we have very good moral reasons to keep the distinction. It doesn't mean that we shouldn't make intelligent systems, we should, but maybe not to that extent that we should then grant the same rights as humans.
I think it's a fascinating question, and I think I'd like to thank you for your talk, but I think we need to explore even further the implications of AI, because okay, what if we had an autonomous vehicle that was then ferrying everyone around, had a list of all of its manifest of every passenger that ever took it, its billing system, its rating system, and it was capable of actually functioning as a or a fully autonomous but semi-independent vehicle. I don't know that you would want to take away the right to privacy, or how you would actually regulate who has which access to such a device.
So you should certainly regulate privacy rights of people using this. Actually, I know in the UK they already have an experiment with a self-driving car. This car actually reduces the buying behavior of people, and it is for free, but it will take a route that it goes along the shop that it knows you inclined to buy things. So this
Also
is a very
good.
interesting question. Do we find this
Acceptable?
acceptable? I mean, from a business point of view, it is a very good business case, I would say. But do we also? I don't have very strong opinion, but I think these questions we should pose here.
Yeah. Well, thank you again. Thank you. I'd like to now introduce actually one of the people who I respect most on the planet when it comes to information security, Mikko Hipponen, and I hope I'm pronouncing that correctly. He's the Chief Research Officer at F-Secure, but he's been doing this for a very long time in terms of being at the forefront for information security. I know him because he's worked on major malware campaigns for the last 20 years. He's been prominent in Hipponen's law around IoT devices. I'm actually secretly really jealous about the fact that Vanity Fair named you Code Warrior. That is just way too cool. He has the most watched TED Talk. All right, this is amazing that you're here. Thank you so much, and it's my great honor and pleasure to introduce Mikko Hipponen.
Thank you, Jaya. Thank you for inviting me. Thank you for having me here. Thanks to KPN for hosting the event, which is exactly on the right topic. Machine learning, artificial intelligence, the world around is changing. And change is scary. Yes, it is. So it's okay to be scared about these big changes. It's okay to be scared about our jobs. It's okay to be scared about the future of security, both real-world security, but also computer security. And computer security is where I've spent my whole life. Now, those of you who have seen me talk before know that I often carry with me a floppy disk to remind myself of where I'm coming from. This is infected by form.a, which is a virus which I reverse engineered in 1992. I've been doing this for quite a while. But nowadays I've actually started carrying something else with me as well. This is a punch card. A punch card. This is the way we used to store data in the 1960s. Now, my mother, Rauha, went to work for the Finnish State Computing Center in 1966. Nobody worked with computers in 1966. My mom did. And of course, that's the reason why me and my two brothers all ended up working with computers. Because as a small kid, me and my brothers would play around the house with punch cards and punch tape our mom would bring home from work. Now, if you think about this change, the change from data stored on paper to the thing you're carrying in your pocket, which is most likely storing 128 gigs or 256 gigs or maybe half a terabyte of information on silicon chips. That's a pretty big change. And all this has happened during one lifetime. What's that? Well, that's a revolution. That's a revolution. That's a technological revolution. In fact, we are living through revolutions. We are living through multiple technological revolutions in one lifetime, which is remarkable. I believe that if we live long enough, we all will see 3 technological revolutions in one lifetime. The first one already happened. That's the internet revolution. The internet revolution, which is easy to understand when you think about how computing has changed. This is our website in 1994. I set up the first website for F-Secure in April 1994, which was pretty early in the web. How early? Well, our website was website number 16 in Finland. All right, there were 15 websites in Finland before our website. Yes, F-Secure is from Finland. I live in Helsinki, so that's why Finland. Nevertheless, when I think about my early days with the company, around 1991, 1992, when I joined the company, the computers we were using looked like this, but unlike this computer, they were not online. This is 1994, so this thing is on the internet. In 1992, our computers were not on the internet. They were not even connected to a local area network. We were a computer company, an IT company. We had computers on every desk, but those computers were not connected to each other. In 1992, we didn't have a LAN. We were using floppies to move files around. Then we got a LAN, then we got an internet connection. So this is the internet revolution that happened. We had computers before the internet, but during our lifetime, every single computer has gone online. Today, it would be hard to find a computer which would not be online. So this revolution, the first revolution, it already happened. Today, every computer is online. Good. Now we are in the middle of the second revolution. If the first revolution was about computers getting online, the second revolution is about everything else going online. You might call it the IoT revolution, or the revolution of connected things, or connected devices, or ICS revolution, or what have you. It's a revolution where everything will become a computer. Everything will become a computer if it uses electricity it will be online. And yes, as Jaya mentioned in the introduction, there's a law named after me. It's actually on Wikipedia. It's the Hyppönen law, which says that when something is described as smart, what you should be thinking is vulnerable. So, here's a smartphone, a vulnerable phone. Here's a smart watch, a vulnerable watch. Smart car, smart city, smart grid. You get my point. Why are they vulnerable? Because they are connected. If you have a traditional wristwatch that you have to wind, you can't hack that. How do you hack a wristwatch? You don't, because it's not on the internet. You can't hack it no matter what you do. But when you get a smartwatch which is on the internet, at least in theory, it can be hacked. Yeah, and yes, this is a very pessimistic law. Indeed, it is. But it's also true. Now, the fact that everything will become a computer and everything will be on the internet can be challenged. But I think it's going to happen. And I think it's going to happen for different reasons than what most people think today. Because today, we're at a very early stage of this revolution. Yes, we already have IoT devices, but they look quite different from what they will look like in 10 years or 15 years. And the main reason why they will look different is that it's still pretty expensive to buy an IoT chipset. An IoT chipset, basically the difference between a stupid appliance and a smart appliance, costs somewhere in the range of 10 euros today. And that's a lot of money when you consider the cost of typical home appliances, like washing machines or toasters. A toaster will cost you 30 euros. You cannot put, even if you want to, and I don't know why you would want to, but even if you would want to put a toaster on the internet, you can't actually do that commercially, because it would increase the price by 25%. And the most important selling point of home appliances is price. But as we know, the prices of technology is plummeting constantly. It's the reverse of Moore's law. The price of existing computing power halves every 18 months. So in 10 years, an IoT chipset will not cost 10 euros, it's going to cost 10 cents, or 5 cents, or 2 cents, or half a cent. And when they're that cheap, things will change. Then vendors who build appliances and home machines, toasters and washing machines, they will start putting those chipsets into everything. Why? Because their chiefs and their boards have been in a Gartner briefing where they have been told that data is the new oil. So these executives go to their engineers and they will tell their engineers that, hey, we've heard that data is the new oil. How do we get some of that data? And the engineers tell them that, well, we'll just put all of our devices on the internet and we'll get a lot of data. All right, let's do that. No, we can't do that. Why? Because it's too expensive. But in 10 years, it won't be. So in 10 years' time, when you go shopping for a washing machine, you can either buy a smart washing machine with an app, with a display, things like that, or a stupid traditional washing machine. But even the stupid traditional washing machine will be on the internet. They just won't tell you. Because it's not on the internet for you, it's on the internet for them. Because they want to know where you are. They want to know how often do you wash clothes. They want to know how often they have error situations or failures. How often do their washing machines catch fire? They want to know things like that. That's valuable information. It's not very valuable, but it's probably more valuable than the price of a 2-cent IoT chipset. And no, you won't be able to prevent that machine from going to the internet, because it's not going to go to the internet through your Wi-Fi. It's going to go to the internet through 5G or any of the new future connectivity technologies that we are developing right now. So the IoT revolution will happen, whether we like it or not, whether we play part or not. And then we have the third revolution. AI. AI fueled by machine learning. Now, machine learning is an everyday technology. It's being used everywhere around us. Narrow AI is an everyday technology. It's being used everywhere around us. But then real, strong AI is way, way in the future. Whether it's going to happen during our lifetime or not, we don't know. It could. It depends partially on how long we live, I guess. But it is possible it's going to happen during our lifetime. Now, narrow AI, like I said, it's everywhere around us. Typical example would be Google search. You know how you're Googling for something and it fills you automatically. It guesses what you're about to search. And you've only typed a couple of characters and it's already guessing what you're searching for. It fills it in for you. That's narrow AI. Or when you make a mistake and have a typo in your search and it fixes it for you. Like, That's narrow AI. That's pretty good. I mean, that's not even close to the actual search. But that's what I was searching for last night. No, not really. But nevertheless, that's narrow AI. But this is obviously still far away from the things that we see in the movies. Things that we see about machines becoming smarter than we are. Now, the guy that hired me in 1991 to join F-Secure, his name is Risto. He's still our chairman today. During these years, he's taken many new roles, the most important of which is that he's today also the chairman of Nokia. He's the guy that actually saved Nokia 5 years ago in the crisis of the mobile phone business dying by selling it to Microsoft and then using that money to buy Alcatel-Lucent and turning Nokia from a handset manufacturer to a base station manufacturer. Of course, he didn't save Nokia, but he's part of the process. He didn't save it by himself, what I'm saying. He's part of the process that saved Nokia. And for years, when we were discussing machine learning within F-Secure, I remember that the top management was asking questions about, like, how does it actually work? Like, how do we actually do this? In fact, Risto, our chairman, got so interested in this that he actually went back to school to start learning, programming machine learning systems himself, which is pretty remarkable. Like when you have a top-level leader, chairman, who wants to understand the technology which is shaping the world around us so badly that he goes back to school and starts programming these themselves, that's pretty remarkable. And for the past 2 years, he's been on a mission to convert other leaders to understand this. Basically, machine learning is going to shape every company. It's going to be crucial to every company, which means the leaders of every company should understand how it actually really works. Like, what is this thing for real? And he's been doing writing and lecturing about this, and I actually recommend you to go and watch one of his videos where he talks about this, and make your boss watch the video. So when you Google for why you should study AI, and maybe Nokia, why you should study AI, you'll find his lectures about this topic. Send them to your boss. Make sure they watch it to really understand how these things work. How do they learn? And one crucial lesson about machine learning is that machines can't learn if they don't have something to study. And that something is data. This is why we keep saying that data is the new oil. The more you have data, the more you can use it for data analytics, the better you can understand your customers, the better you can understand your business, and the more data you have to teach to your machine learning systems. And the lesson there is that even if you're not doing machine learning right now, you will be, and your company will be doing machine learning in the future. One thing you can do already today is to start collecting data that you can use in the future to teach your systems, even if you don't have those systems today. So, from narrow AI to strong AI, things that are smarter than people. That's a scary thought, and it seems like a basic evolutionary mistake to introduce a superior intelligence into our own biosphere, doesn't it? This never ends well. But is this even possible? Like, how could we build something that would be smarter than us? Like, even if we build, tons of different narrow AIs, and clearly we can build narrow AIs, how do we combine them with each other? How do we make things understand the real world? We keep moving the goalpost on what we mean by artificial intelligence. I remember reading technical magazines in the 1980s, which were already speaking about artificial intelligence. And back then, I remember this, they were saying that, one day we will have a computer which is going to be smarter than a human. It's going to be so smart it can beat the best chess player on the planet. Well, that happened 20 years ago. IBM Deep Blue beat Garry Kasparov in chess 20 years ago. And when that happened, we sort of changed our minds. We didn't think that, okay, now computers are smarter than humans. We just said, well, it's just calculating stuff. It's just calculating all the movements. It's not really smart. It's just a calculator. So we keep moving the goalpost. So let's try to imagine something that everybody would agree that, okay, now that's smarter than a human. A definition of strong AI that we would all agree on, that, okay, that's smarter than we. What could that be? Well, how about a full-size simulation of the whole human brain? If there would be a computer that could simulate all the synapses and all the neurons that are in a human brain, well, then that would be, for all practical purposes, the same as a human without the body. It could think everything we can think. And there are multiple projects like this underway right now. In fact, some of these projects were started already more than 10 years ago. Projects where scientists, companies, and universities are trying to build full-scale human brain simulators. This is very, very hard. We're not even close. But as computers get better and better, faster and faster, as we can fit more transistors on silicon chip every year, I think eventually this could be doable. Eventually we might be able to have a system that could do this. Initially, it would have to be a whole data center simulating one human brain, and it would only be able to simulate one human brain at a speed which would be 1,000,000 times slower than a real human. Initially, it's going to be that bad, like a huge data center, and it would be very, very slow. But then, every 18 months, it would double. Eventually, it would be as fast as a real human brain. Then 1,000,000 times faster. Then 10 billion times faster, which would be smarter than all humans combined. It would be just like us, just much, much faster. Is this possible? Many people think it is. We don't know how long it will take. But I think everybody would agree. If we would really have a full-scale simulation of a human brain, which would be faster than a real human brain, then that would be superhuman intelligence. That would be strong AI. And if we reach this, everything changes. Because it is, for all practical purposes, human. If you would talk with this on the phone, and of course it could speak, of course it could, it's a brain, it can speak. You just attach it to a speaker and it can speak. If you would speak with a simulated brain on a phone, you wouldn't be able to tell the difference, because there is no difference. A simulated brain would dream, it would be sad, it would be happy, it would seek for love, it would want to work, and it could work, it could earn its living, obviously. Write books or write articles or, I don't know, program, run websites, whatever. It just doesn't have a body. It definitely would date. because that's a basic human need, and it is a human. And this is part of the question why I asked about privacy. Like, if we are ever to reach this, do we want to grant privacy rights to it? And I don't know. I'm glad we don't have to decide yet. For today's technology, I'm confident we shouldn't grant privacy rights. For example, the drones. Like when there's a drone buzzing there somewhere, we humans must have the right to know whose drone is it and why is it there and what is it doing. There must be no privacy limitations restricting us humans from knowing why a particular drone or robot is doing something. But when we get to this level, maybe things change. It's funny to think that a computer could, I don't know, dream and write poems. And of course these would make almost all of our jobs irrelevant. Like every programmer is out of a job immediately. I'm out of a job immediately. Which is an uncomfortable thought, isn't it? But clearly, if we have a superhuman brain which can program and be a million times faster than a real human, there's no need for us to do any of that. And of course, this is not the first time we see technology make humans irrelevant. If you think back a couple of hundred years, there was another big innovation. Artificial power. When artificial power was invented in the form of steam engine and then electrical engine, a lot of people got unemployed. Because there were a lot of people carrying bricks around and a lot of people doing physical work which we replaced with artificial power. And yes, a lot of people were unhappy about artificial power because they lost their jobs. But I think we, as a humankind, are much better off by having invented artificial power than not having invented artificial power. Same thing is going to happen here. Once we figure out artificial intelligence, it's going to make a lot of us irrelevant in what we're doing today. But it will be probably better for the humankind. Of course, the transition, if this would ever happen, would have to be very, very carefully done, because we only get to do the transition once. When we go from being the smartest being on the planet to the second smartest being on the planet, then we no longer call the shots. So we have to be very careful to define the rules while we still can, before we cross over, if this were to happen. But I think that would be the definition of strong AI, that everybody would agree would actually be smarter than a human. So security and safety of machine learning and artificial intelligence. I've worked all my life with security, in particular computer security. In many ways, we're fighting a war. And in many ways, it's not a fair fight, because our enemy has access to our weapons. What I mean by that is that we build security technologies like filters and gateways and proxies and intrusion prevention systems and firewalls. And then the attackers create their new attack, for example, new malware or a new exploit. And before they start their attacks, they will go and download all the security products and try their attack against these safeguards in their own systems to see if they are being blocked. For example, when malware creators write new malware, they always scan them against all possible antivirus systems before they release it. And they have unlimited time to do this. In most cases, their new attacks are initially blocked by the current technology, but that's no problem. Then they will just change it. They will modify it. They will add layers of obfuscation and encryption and retry, modify and retry until it goes through today's technologies. And then they will release their attack. And they have unlimited time to do this. And we defenders don't. We must be able to detect and stop such attacks immediately. So it's not a fair fight between malware writers and malware fighters when the attackers have access to our weapons. And we defenders have to success every time. The attackers only need to get through once. Defending is hard. It's especially hard when you look at the amount of attacks that we are seeing. The attacks are going through the roof. We've never seen more activity on the internet from the attackers than what we are seeing today. We're seeing new kinds of attack technologies, new kinds of exploits, new kinds of malware. And when you look at practical examples where machine learning is being used today, security is a very good example. All security products use machine learning today. They use it because they have to. There's no other way to keep up. We have been using machine learning inside our systems for almost a decade. Initially, though, we didn't call it machine learning. We didn't call it artificial intelligence. Why? Because we're not very smart. It would be very smart marketing to call it artificial intelligence, but we didn't think like that. I guess we should have. What we initially started doing was just automating the work of our researchers. Our analysts and researchers, our human researchers, look at incoming attacks and figure out how to block them. They look at incoming samples and figure out, is this a good program or is this a bad program? Should we allow it or should we block it? Is this a good website or a bad website? Should we block it? Is this email spam or is it something genuine? Should we block it or not? And we've moved this work from humans to machines. I still remember a meeting around 8 years ago where our CTO said that, we can't keep up with the amount of malware samples. Like we're receiving thousands of malware samples a day and we can barely keep up and the amounts are growing. We can't keep up. We have to start automating our work because otherwise, how are we going to survive if we would one day receive 100,000 samples? That's what he said 8 years ago. Today we are receiving close to 1 million samples a day. Not 100,000, 1 million. There's no way we would be able to keep up without labs automation or machine learning. So we started looking at the work being done by our human analysts and started moving that work from humans to machine. And the crucial property of this system is that it has to be able to learn. It has to be able to learn. It has to be able to teach itself. It has to be able to make the distinction what is good and what is bad. So today, we're running a massively large system which is right now on the internet running hundreds of machines which are browsing the web with a machine running Windows XP Service Pack 0 with no firewall, running Internet Explorer with Java and Flash enabled and surfing mostly pirate and porn websites and clicking on every link. Why do we run systems like that? Because we want them to get infected. Why do we want them to get infected? So we get samples. And by the way, they're not really Windows XP machines. They're actually Linux servers pretending to be old, out-of-date machines. And through that kind of system, we're able to collect hundreds of thousands of malware samples. Then our automation system takes them in and throws them into a virtualized network with dozens of different kinds of machines running different operating systems, running these samples there, and then analyzing the output, trying to figure out, was this a good program or was this a bad program? We do this hundreds of thousands of times a day. And the system learns. It looks at what programs do when you run them. And then it makes the call. This is a bad program. This is a good program. And then sometimes it can't make the call. Sometimes it doesn't know. It doesn't know is it good or bad. So then it escalates it to a human, to our analysts. And now, crucially, our analysts don't go and look at the sample and make the call that, yeah, this is bad or this is good. No. Instead, the human goes there and teaches the system so much that it is able to make the call for this sample, which means it's going to be able to make the call for similar samples in the future as well. Now, this is doable. We use this in production. We've been doing it for years. It works, but it's not easy. It can make mistakes. Clearly, it can make mistakes. Let's take an example. Stuxnet, one of the most famous malware cases in history. Stuxnet 2010. Stuxnet created by the governments of United States and Israel. Stuxnet, the attack which attacked the nuclear enrichment systems of Iran. That Stuxnet. When we got the first sample of Stuxnet, it went through our systems of the time. We were already using labs automation at the time. Our systems and all the competitor systems, none of them figured it out. None of them realized that this is malware. Why? Because it didn't look like malware. Stuxnet was the outlier. It was out of the norm. Normally, malware is compressed, obfuscated, encrypted. Stuxnet was huge. No encryption, no obfuscation, no nothing like that. When you executed Stuxnet on a virtual machine, it installed signed drivers, set up some files, created a scheduled event, and exited. That's what it did. What it looked like was more like a setup program, which would install a driver for something. It looked nothing like malware, but it was. So clearly, automation can make mistakes. It does. It has false negatives all the time. It can also have false positives. And I guess the most problematic cases are cases where the attackers try to attack the system. These technologies are no secret. Our enemies know that we do this. Malware writers and criminal hackers know that they are facing machine learning systems. So they can try to game the system. And we have seen this. We've seen attacks where we get submitted large amounts of samples through our sample submission forms, thousands of samples, which are trying to make the system learn wrong. We've seen this also in spam filter machine learning systems. Most spam filters use machine learning as well. And if you've ever received spam messages in email which don't look like normal spam, you might have actually seen this happen. So what's happening is that you get emails which make no sense, which might have random words in it, but it's not trying to sell you anything, and there's no link. It's not really spam, it's just random words. But these are being sent by spammers because they're trying to trick the spam filter in your system. What they're trying to make you do is to click the button in your email client classifying it as spam. Like it came through all the way to you, so you know that the spam filter didn't caught this, but it's clearly spam. I don't want this mail, it's spam. What you just did is that you taught the system that emails which have random words and don't link anywhere and don't trying to sell you anything and don't have any words related to Viagra or whatever they're selling in spam is spam. You're just teaching the system wrong. And this is what they're trying to do. They're trying to make you teach the system wrong so it wouldn't work. I often say that our work would be so much easier if our enemy would be stupid. Unfortunately, they're not all stupid. Unfortunately, some of them are pretty smart. So we have to understand who are the people behind the attacks. We have to understand where they're coming from. We have to understand what are their motives. We have to understand what they're trying to do. And over the years, I've met face-to-face many online criminals, quite often in a court of law, sometimes in jail, sometimes somewhere else. But when online criminals get caught, the one most common story I hear from them is regret. Because obviously people who are able to write malware or exploits are technically savvy. They know computers, they know protocols, they know how to program. And quite often the case here is that these people are people who had the skills but who didn't have the opportunities. And what I mean by this is that if you know how to program, if you understand TCP, IP, if you understand network protocols, and you're living in Rotterdam, or Amsterdam, or London, or Helsinki, you will get a job with your skills, no problem. But if you have the same skills, and you're living somewhere in Siberia, or in the countryside of China, or in the slums of Sao Paulo, you won't get a job. And the easiest way for you to turn your skills into an income is to go into life of crime. And this is a huge waste, of course. One of the best ways we can fight online crime is to make sure that the people who have the skills but don't have the opportunities would get the opportunities. So what's the likelihood that online criminals would be using machine learning against us? This is something we haven't seen yet. Let me be clear on this. We haven't yet seen online attacks which would be using machine learning. There's been some studies into this, some academic speculations on what could happen. In practice, we haven't seen this yet. We haven't seen polymorphic malware which would learn how to change its code on its own. We haven't seen email worms which would auto-generate the email messages and learn what would work and what wouldn't. These are attacks which are doable, which we haven't seen yet. Now, eventually we will. Eventually there will be attackers who will be using machine learning against us. It's highly likely to happen. But I believe it's not likely to happen in the near future. And the reason why I believe that is that there's a different lack of talent in this space than anywhere else. There's a big lack of talent for security people. There's job security in security. We have a talent gap. We're trying to find people to work in security. But that's far away from the talent gap we have in machine learning, artificial intelligence, and data analysis. If you know how to program machine learning systems, you're in high demand. You're in high demand all over the world. If you know how to program machine learning systems, you will get a job regardless of where you are in the world. Some company will hire you, will fly you into any city in the world where you want to work and will give you a high-paying job. That's how big demand there is right now for machine learning people. Which means if you have the skills in this area, you will get the opportunity. You don't need to go into life of crime. You can get a well-paying job, legal job. And most of the online criminals would rather have a well-paying legal job. It's not nice to always be looking around your shoulder, always be worried about getting caught. If they can get a well-paying job, and it doesn't have to be as well-paying as a criminal job, just good enough, they would rather take that. Most criminals would rather take a legal, well-paying job than continue the life of crime. And this especially applies to online criminals. And I wish that this talent gap is going to postpone the first intelligent attacks, first machine learning attacks, at least by a couple of years. It's not going to last forever. Eventually these systems will be easy enough to use. They will become accessible to every idiot on the internet eventually, but hopefully not in the near future. We haven't seen machine learning being used for bad yet. We are seeing machine learning being used for good in computer security all the time. Hopefully this will last as long as possible. And when it changes, when it won't last anymore, then it's highly likely that the change will start from the most powerful attackers on the internet. And the most powerful attackers on the internet are not criminals, they are not organized crime, they are governments. Because governments use offensive cyber power all the time. Governments use cyber weapons all the time. Governmental intelligence agencies use cyber weapons all the time. Because from the point of view of militaries, cyber weapons make a lot of sense. Cyber weapons make a lot of sense. These guys are pretty good at marching, aren't they? Pretty impressive, huh? I've seen your army march. It doesn't look like this. Don't get me wrong. I have high respect for your army, and especially for your intelligence agency. They've had some pretty remarkable success stories lately. So, points for that. But why do governments like cyber weapons? They like cyber weapons because cyber weapons are effective, affordable, and deniable. Effective, affordable, deniable. That's a pretty good combination in a weapon. It's effective, it gets the job done. It's affordable, it's cheaper than the alternatives, and you can deny that it's yours. And deniability is very powerful in the world of intelligence gathering and spying, and in the world of conflict and wars. So it's no wonder governments are interested in these. There's also, or at least has been, quite different reaction to governmental hacking. This is why it's so important that we're now seeing a change in this. We're now seeing governments openly saying what other governments are doing with their offensive cyber power, naming names, sending them away, saying that this is not okay. This is very important. So governments might have the first mover advantage in using machine learning for offensive use. And this is a worrying thought. And it clearly reminds us of the fact that we need to have some level of rules in this space. Like what is allowed and what's not allowed in war and in peace. Rules of war for cyber war. Rules of engagement. Eventually we will have completely autonomous weapons. We don't have them yet. I mean, easily we could build them today. We already have, for example, between the border of North Korea and South Korea, completely automatic weapons built by Samsung, which could find targets and shoot them and kill them without any human assistance, but they don't, because we choose to have a human there pushing a button. The human is not needed, but we choose to have a human there just because we think that if we kill someone, the decision is made by a human and not by a machine. But eventually this is going to change. And why it's going to change is pretty obvious when you think about things like drones, which are being used in massive scale in all current conflicts. Drones which shoot missiles and kill people. Those drones today are being controlled by humans. Humans which could be thousands of miles away. So it's a human making the decision. But the more you think about it, the more you realize that the weakest point in drones is the control channel, the control channel between the human and the drone. Because that control channel can be intercepted, it can be spied on, it can be target of injection attacks, so somebody could send wrong commands. At the very least, it can be jammed. You can always jam a connection just by sending other signal to drown out the real signal. And if that's the problem, then the obvious solution is to take away the control channel, remove the human, just have the drone fly on its own, find the target on its own, kill the target on its own, and return home. That's why it's likely that one day we will have machines which will make these decisions on their own. And that's why we should be thinking about whether that's okay or whether it's not. I don't think it's okay. I'd rather not have a machine make the decision whether a human can live or die. But if we don't worry about this now, we won't be there to make the decision when it matters. Another thing which is changing, partially in the attacks done by governments, partially in the attacks seen by criminals, is that we are seeing more and more attacks which don't target computers, but target something else. We are returning to the second revolution, the IoT revolution. Everything is becoming a computer. Your television in your home is already a computer. Your washing machine might not be yet, but like I told you, it will be. And we are seeing larger and larger amounts of attacks targeting these things. And everything will be online, whether it makes sense or not. So let me give you an example. There's a company in Spain building smart mattresses. Yep, you heard me right. This company right here. Mattresses that you sleep on. Sleeping mattresses with sensors built into the mattress. And I'm sure you're wondering why on earth you would buy a mattress which is on the internet. Well, it comes with an app which will warn you when you are out of your house if it's detecting that your bed is being used in a suspicious way. So you get an alert, you get intensity, you get impact. And this is not a joke. It is a real product. And of course it's being made in Spain, of all countries. Maybe in Italy, I don't know. So yes, everything will be on the internet. When we look at the amount of botnets that we have found which do not infect computers, the growth rate is clear. The most famous IoT botnet is Mirai, which we found in the summer of 2016. Mirai now has dozens of variants of it spreading on the internet, none of which are infecting computers. And when we were analyzing the first Mirai attack, we were actually on the internet fingerprinting infected devices to figure out what they were. And what we found were security cameras infected by Mirai, smart doorbells infected by Mirai, home appliances of all kinds. And we also fingerprinted some of those devices so that we actually figured out where they are, even figured out which company it was which was infected. And this Mirai botnet was used to launch one of the largest denial of service attacks in history. So I picked up the phone and called some of these companies. Hello. This is Mikko from F-Secure. Hi there. Do you have a Hitachi heat pump in your office? Yes, we do. We believe your Hitachi heat pump is infected by a bot and it's right now launching a denial of service attack to take down the root DNS servers of the internet. You know what he answers? Really? Cool. Which is not really the answer you're looking for, is it? So many people thought Mirai was the wake-up call we needed for IoT security. It was not the wake-up call. The victims of Mirai didn't care. The Hitachi heat pump in this place was working fine. The fact that it was causing problems to somebody else, that's not their problem. We will need a bigger disaster for people to wake up. And we have a word for big disasters that can happen in the world of IT security, but are unlikely to happen in the real world. We call them movie plot threats. Things that could be done, but only are really done in movies. So for example, when you think about car hacking, the idea that your car can be hacked remotely and someone can floor the engine and disable brakes, we immediately think about risks where hackers would kill us with cars. And that's a movie plot threat. I mean, it can be done. It's technically doable, but it's unlikely to happen. Why? Because hackers are not interested in killing people. But movies do this. So if we play a clip from Fast and Furious, in the latest Fast and Furious, part of the plot is about using cars as weapons, taking over all the cars in the city and using them as weapons. And this is a movie plot threat. And I'm sorry if I'm spoiling the movie plot to some of you, but it doesn't matter. It's not a very good movie. So this is what car hacking looks like in the movies. This is not what car hacking looks like in the real world. I mean, this is doable, but it's not going to happen. It happens in the movies. In the real world, what car hacking looks like is completely different. It looks like this. This is real world security footage of two hackers. That's not a pizza box, that's an antenna. The other hacker is by the car. They're trying to find the car keys from inside the building. They find it, they emphasize the signal. They use a transmitter to get the signal inside the car. Then they get the driver in there and they drive off with the car. This is what car hacking looks like in the real world. It's not about driving you off a cliff. It's about stealing the car from your driveway by hacking to open the car doors, by hacking to get the car started and driving it away. I especially love the fact that the two hackers who had the technical know-how on how to open the cars, they were not the ones driving it away. They probably were worried about crashing the car or something like that. But they had a driver, the third guy, to drive the car away. And if we think about these attacks, then it's easy to forecast what's going to happen in the future. When self-driving cars are a reality, and they will be during our lifetime, I forecast that someone somewhere will convert a self-driving car into a self-stealing car. You wake up in the morning to realize your car has driven off on its own, and it's now somewhere in Poland. Where do they take stolen cars from here? I don't know, actually. To Finland, all right. I deserve that, thank you. And part of the puzzle in securing IoT devices, whether we're speaking about cars or fridges or washing machines, is not just that they are insecure by default, it's also that the users don't care. Users could use them more securely, but they don't. They could use strong passwords. They could put them in a separate network segment. They could change the default settings to more secure ones, but they don't. And this reminds me of VHS players. Remember these? Video cassette players from the 1980s. We used to all have these in our living rooms. Whenever you would visit your friends, they would have one of these in the living room. And every living room all over the world which had one of these, every player was displaying the same thing on screen. Every single one of them was blinking 12 o'clock. Why? Because when you boot up, when you install a VHS player, it doesn't know what time it is. And now it's expecting you, the user, to go and read the manual. Because somewhere on page 80 in the manual, it explains to you how to set the time, how to change it, And then it stops blinking 12 o'clock. But we never did that. No one ever did that. Well, in fact, I mentioned this example somewhere else, and there was one guy in the audience who said that I actually changed the time in my VHS player. And I asked him, "Are you German?" He was. And this is what we're doing with our IoT devices. When you buy the new security camera, it's going to be an IoT device. All security cameras today are small Linux servers with a HD camera and a encoding chip. We buy a security camera, we take it home, we unbox it, we put it on the wall, we install the application, we pair the app with the camera, and it works. It works. Look, it works. Don't touch it. Don't change anything. No, it works. That's what we do. We never read the manual. The manual would explain to us how to segment the network, to keep the video stream in the public internet, but to keep the admin interface out of the public internet, so it can't be hacked. But we don't do it. Just like we didn't do this. Except maybe that one guy in Germany. I'm sure his IoT security camera is securely configured. And if this is true, then it's easy to forecast what's going to happen. So I'm going to forecast human uprising against the robots. And yes, you heard me right. Human uprising against the robots. And I know what you're thinking. You're thinking Terminator 2. That's not what I mean. I don't mean Terminator 2 at all. I mean trash cans. And trash can sensors. The yellow thing there in the trash can, that's an IoT sensor. This is a smart trash can. And this is actually a good idea. There's a startup making these sensors that you can put in the trash can. The idea is that the city puts a sensor like this in every trash can in the city. And that sensor is going to report the location of the trash can and how full the trash can is. So then the city can optimize how the trash trucks drive around the city emptying the trash can. That's pretty good. That's good for the nature, that's very green, we like this, smart idea. However, the company that built these, when they started deploying these in real cities, ran into problems. The problem was that these sensors were coming back broken. And they are very hardened devices. They're not supposed to break. They're supposed to be inside of a trash can. They shouldn't break easily. Nevertheless, they were coming back broken. And not just being broken a bit, they were coming back horribly broken, in pieces. They couldn't figure out why they were coming back broken until they started looking at security cameras in which they saw that they were actually being broken on purpose. They were actually being hit and smashed into pieces. By who? By the truck drivers. The truck drivers hated these sensors, these yellow things, before which they would go around the city every week. Now they would only go around the city every month. These yellow things were taking away bread from their table. They hated them. And this, my friends, this is the human uprising against robots that I mean. It's not about Terminator 2. It's about truck drivers smashing smart trash can sensors into bits because they want to keep their job. So whenever we speak about robots or smart technology, especially if you go to YouTube and look at videos about robots, there's one thing which you almost always see, which is that you see how someone is demonstrating how agile these intelligent robots are by kicking them. And this is a bad idea. Like whatever you do, don't do this. Do not kick the robots. Why? Because eventually the robots will be smart enough to go to YouTube and watch these videos. When the artificial brains are real, they will see this and they won't like what you did. And they will be smarter than you. They might want to kick back. Don't kick the robots, please. We humans like to humanize these new technologies. I don't know how much it makes actually sense to build technology like this, which is trying to be like real living things are, but they are being built. There's even a band, I don't know if you've heard of this, but there's a band called Compressor Head, which is made out of robots, which play real instruments, they play real songs. I'll actually play you a clip. So, if we look back to where we came from, look at the technology changing around us, we are living in the middle of revolutions. Everything is becoming smaller and smaller, cheaper and cheaper. Everything is becoming a computer. We already lived through the internet revolution. Now we are in the middle of the IoT revolution. And if we live long enough, if we go jogging and eat salmon and salad, we will live long enough to see the third revolution, AI revolution, in our lifetime. And a great example on how technology is changing fast is this computer, our website from 1994. This is a 486 25 megahertz machine. By today's standards, it's not very fast. But at the time, it was pretty nice. I mean, it was fast enough to run a website. Remarkable. So I wonder, with today's technology in 2018, how small would this be? Like, how small could we make a computer of this power? And the answer is, IBM has announced that they are working on a new chip which is roughly the same power as this 486 25 megahertz, and it's tiny. This is a pile of salt. These are grains of salt, and the black dot there is the computer. This is what happens to technology in 25 years. Now imagine 25 years into the future. We are living in the middle of revolutions. And I think we're lucky to be alive right now. Thank you very much.
So I'm going to thank you for that wonderful presentation, but I'm also think that there might be a few questions. Yep. Wait for one moment. There's a microphone coming to you.
Thank you. I have a question, and maybe I disagree a bit with your phrasing in the middle of your speech. You said that we restrain technology because we want to have humans making decisions instead of having AI making decisions. I think that we don't want to make the decisions. We want a human operator or a human driver to say, that was the best I could do. I'm very sorry I crashed my car. With my limited cognitive ability, I couldn't do it. But if we have an AI, then we come face to face with the decision before the accident happens. The car has to be programmed to hit the older person or the unemployed person or some other person. And we do not want to have to make these decisions to legitimize those decisions, I think.
I agree, and I think a crucial question is within the company that's making that technology, for example, self-driving car, who exactly made the decision? Like, if the technology has been programmed to do something in extreme situations, like it's going to crash and it has to decide whether it's going to crash into a wall, which is dangerous for the passengers, or into a human, which is dangerous for the human on the road. Who exactly made that decision? Like, was it made by a panel within the company, like an ethics panel? Was it made by, the chairman of the board? Was this decision made by the CTO? Or was this decision not made at all? Which means the decision was made by a junior programmer who's at the keyboard. And I'm afraid that in many places it's being done by the junior programmer at the keyboard because it's not actively done anywhere. And this is one of the problems we face.
So I have a small suggestion. You know, you were saying, why do we have this macro detection for the smart mattress? Did you know the country with the highest percentage of Viagra use in the EU is?
Netherlands?
Spain.
Spain, okay.
Netherlands.
Okay, there we go.
Could be an explanation. There was one more question. Yes. One moment, please. Yeah.
Yeah, well, thanks very much indeed for such a great presentation. You made a very strong case that we must make the rules now whilst we still can. At the same time, we probably all recognise that technology is typically miles ahead of the regulator's ability to respond. How do we break that circle? Because it sounds like it's quite urgent.
Well, the answer is I don't know. And I share your worry, because it's not just a question of technology rushing ahead faster than politicians or regulators can adapt. This is more than that. This is a race. This is a race on who's first, because Google wants to be the first. Apple wants to be the first. Microsoft wants to be the first. IBM wants to be the first. And when you are in a race, the one thing you don't do is to stop and look around. Are we doing this safely? Because you're in a race. So the problem is very real, and I don't really know what is the answer, unfortunately.
There's going to be more questions. I'm going to stop for a minute because we are running really over time. It's now exactly 2:59. We're going to have a 10-minute break. Miko is here, as is Ibo, during the break. I would very strongly urge, there are a few questions in the back. Please come forward, talk to Miko. 10 minutes. We're back here for the panel. Is everybody okay with that? Yeah? 10-minute break. I'll see you sharply in 10 minutes. 3:10. So, thank you for all coming back. I see that we lost a few people, but we're going to start now. I'm going to first introduce a speaker who I've had the pleasure of having before at KPN, Thijs van Lieshout. And we met because you were the director of the Veiligheidsregio Midden- en West-Brabant. Very sexy regio.
Very sexy regio. That's
And
sexy name also.
And you know, he's been working with the Dutch Army, the Fire Service Commander, and for security companies such as Falk and Safety Valley.
Mm-hmm.
Safety Valley. But that's really not your biggest passion. Maybe you want to tell them what it is. Well, that's the stuff.
Should that be AI then?
No, kind of.
No, I really am a believer in safety and in creating networks to cooperate together to enhance safety. I think that's the way we also met with KPN. The special work of safety regions is to organize a continuity of our society. So if there is an event, if there's a downfall of critical infrastructure, how to get rid of it and how to cooperate with partners. And of course KPN also for safety regions as a prime telecom provider is a very important partner we'd like to work with.
Thank you.
Is that a good...
That's a much better answer. So I'm going to let Thijs introduce the rest of the panel. So let's give it up for Thijs and the panel.
Well, thank you, and I think we have a very interesting panel. And shortly, if I may, just a second before introducing the panel, why I think this is a very nice convent, and why it's maybe a bit strange that I am now your moderator, because I think out of these people, I know the least of AI, and I think I'm pretty sure about that. Still, it is the prime innovation driver we selected for the coming years to organize safety and security in our region. And maybe I can serve as an interpreter then, or as a moderator. And I may enhance a small example of what happened yesterday. Yesterday we had the big safety policy board in the Netherlands, and it's 25 of our top mayors, the burgemeesters of the big cities, Amsterdam, Rotterdam, Utrecht, Tilburg, Eindhoven. And they all are head of the safety region. So those 25 mayors, they meet up with our Minister of Safety and Justice, Minister Grapperhaus, and we had a number of issues we talked about and how to enhance safety in the Netherlands, and to do that together with the ministry and the municipalities. And one of the topics was what we call the zogenaamde waspaal. Does anyone know what a waspaal is? So the waspaal is the first Monday of the month, 12 o'clock, sirene, the sirens. You know, first Monday, 12 o'clock, weep, weep, weep. Everyone heard it, I guess. What are we doing if you hear the waspaal? Depends on the day, but so if it's not Monday the 1st, if it's today, if now the siren will run off outside, what are we going to do? Radio 1. Radio 1. So where do you listen Radio 1 then? Oh, you are very badly trained. This really worries me. Nobody knows? Weep, weep, weep. Go inside, close the windows and the doors, turn on the radio to your local news provider. So yesterday we had a discussion, shall we get rid of it and instead take modern technology? Alert, direct alert on your cell phone, broadcasting on your cell phone, or maybe direct alerts on television or radio. And those mayors in the room said, but my mother still doesn't have a cell phone. So she's inside the house and she has this old fixed telephone, probably by KPN, with this draaischijf. I don't know what's that in English, you know, with that draaischijf. And she doesn't want alert 1 on 2. So we have now the old siren system with only 70% coverage of the population. We have the new direct alert using all kind of smart messages on the cell phone and giving you exact good information, what's wrong, what to do. It has a coverage of almost 90%, but still it's refused. And it's postponed now for 1 or 2 years because the minister has to go back with our stakeholders to discuss this new technology and to see if it really fits in the mind of our policymakers and our decision makers. So I think we have a long way to go to use the benefits of AI and innovative technologies in our society. Now I'm glad that we have a smart panel over here, and I would like to introduce them to you on the fly, so to say. To make the nation smarter, we have Bob de Wit. And Bob is Professor of Strategic Leadership at Nyenrode Business University and co-creator of the Center of Strategy. Bob has also, together with others, authored almost 18 books, under which a strategic management book which has been adopted by more than 200 universities and business schools worldwide. In 2017, Bob addressed the impact on artificial intelligence during his inaugural speech at the Nyenrode Business University. So please give a hand to Bob. And I will immediately ask one question, Bob. You said you addressed the impact of AI during this speech. Could you elaborate just a bit on that? What was the impact on AI, on what? On our society or on?
Yeah, well, that's a complicated answer, of course.
Oh.
But I think we underestimate the impact of AI, but also other technologies on society, you know. We very often call it even something like Industry 4.0 or something. And what I mean with that is that we assume that the society as we have currently, how it's organized, and how our democracy is organized will remain the same while we get new technologies. And I think it's going much further. I think that not only technologies are changing the way we think, but it will change the whole society. And that's the basic impact of those technologies.
So you agree then with Miko's observations that we will be in a third revolution, and that the third revolution will drive all kinds of changes?
Well, basically, I think it will be even more fundamental than he is saying, because the way that we are organized with democracy, and we are voting on parties on the left and the right, is something that becomes obsolete, because, you know, we're entering a different kind of society. We are leaving an industrial organized society. We're coming into a different kind of society. We are also developing a Sapiens 2.0. We are developing new kind of organisms that are our natural enemies. I mean, that's going to change our society. So I think it's much more fundamental than that.
Okay. Thank you for this introduction. Then we have Jelle van Haaster from the Ministry of Defense trying to make our nation safer. Jelle, don't
Again?
you? Yeah, please. Jelle is an award-winning writer. He won a lot of awards, already very young. Software programmer, developer, and speaker. He is an officer of the Royal Netherlands Army and has a diverse background in legal, military, and technical defense matters. Jelle recently developed an award-winning software app for effectively utilizing social media during military operations. And he's the author of multiple scholarly IT law, IT, and military operational publications. So Jelle, you designed an award-winning software app for during military operations. To what extent differs that from other software apps we use to read social media during crisis or in normal day-to-day business?
Yeah, very interesting question, because we as armed forces tend to forget that Africa, for instance, where we currently are deployed, that there is internet there, so running water is a problem, but the internet works over there. So when we are getting deployed, then the first thing we do is hand over our smartphones, we leave them at the base and stuff, but you have very strange situations that we drive for 2 hours through the desert, asking a local whether everything is all right, if there are any issues. That local is looking at us with a slightly funny stare and goes like, why couldn't you just send a text message asking this very question? So we tend to forget all that kind of stuff, and that we can deploy data mining tools and data mining software in mission areas, yeah.
And what's particularly then that it will work with the military systems and the military
Yeah, exactly, so
system.
map the environment and stuff, yeah.
Okay, thank you. Then we have an embedded pirate over here, as we might call it. We have Matthijs Pontier. Pontier, is that correct, Pontier? Matthijs is a scientist and activist, and you can see that he's not wearing, oh he does, he's not wearing his tag. I thought that was maybe an act of rebellion. And he's part of the political party, the Piratenpartij. I don't know if we have that in other countries as well. Matthijs studied artificial intelligence as well as cognitive psychology and obtained his master's degree in the direction of cognitive science. As a scientist, Matthijs focused on the ethics of artificial intelligence, and he designed ethical decision models for computers and robots. Next to that, he was the first Dutch scientist who signed the pledge against killer robots. And also a member of the City Council of Amsterdam.
No.
No? Shadow Council?
I'm in the waterschap.
Oh, in de waterschap.
Yeah.
The watership. Is that? We will explain that later on. It's difficult. But you said you designed ethical decision models for computers and robots.
Right.
How does that separate, or how does that vary from ethical decision-making models for humans?
Well, actually, I was trying to mimic ethical decision-making by humans, and of course, human ethical decision-making is very complex, so it was just a simplification of that, to be honest. So what I first did was study emotional intelligence, so mimic emotional intelligence, human-like emotional intelligence for computers and robots. And then when I was working on this ethical decision-making models, I found out that it was very important to add human emotional intelligence to have human-like ethical decision-making. So, for instance, you have this trolley dilemma and a footbridge dilemma. So in a trolley dilemma, there's a train running and it will drive over 5 people and kill them. And you can set a lever so that it will only kill 1. In the footbridge dilemma, you're standing on a bridge and you can push a guy in front of the train, and there are some people working with ear protection. So then also, instead of killing these 5 people, it will kill this 1 person that you push. And if you ask people, would you set the lever for the train to take another track, then almost everyone does that. But if you ask them, would you push this guy in front of the train, then almost nobody does that. And that has to do with emotional processing. And then to be able to program this difference, it was important to add this emotional intelligence.
So pushing is more difficult than a technological solution.
For humans, yeah.
For humans.
Yeah. And now if they use this model with emotional intelligence also for computers, and then it's another discussion if you want this and in which case do you want this, but that's a different thing. But at least I think it's important that if machines make decisions over us and of which we are the object, it's at least important that they understand human ethical decision making and can take that into account and also can explain their decisions to us.
Okay. Okay, thank you very much. Then last but not least, we have Gerard Smit from IBM, please. So it's making the nation smarter, making the nation safer, setting individuals free, maybe, from the pirate party, and IBM definitely making the nation more wealthy if you pay tax. But you said you couldn't elaborate on that. As a company, of course.
Exactly.
As a company,
it's
of course.
Complicated. Yeah.
Gerard Smit is IBM's Chief Technology Officer and Technical Sales Executive for Belgium, the Netherlands, and Luxembourg. He also leads the IBM Center for Advanced Studies and University Relations team. And Gerard, I also read that you are a member of the Distinguished Engineers within IBM.
Yeah.
Is then there also a group of non-distinguished engineers?
There are the rest, that is 349,500 non-Ds. Yeah. And I'm one
so
of
what
the
does it
500.
do, and what do you deliver then for the company with that small group?
Yeah, we are looking more or less to what kind of technology impact AI and quantum computing and blockchain has on business models of organizations. So what my colleague in Finland said about the tiny chip, the multi-computer, is not 25 years. It is only 5 years away from now. Okay. So we are going to put that kind of technology, chip technology, onto products. And with this, we are able to connect blockchain transactions into the real physical value chains of organizations. And we are also deploying that, for instance, here in the Port of Rotterdam, because the Port of Rotterdam wants to invite the first autonomous ship in 2030, and currently we are building already with a couple of partners a whole IoT environment powered by AI technology that we can track and trace all kinds of shipment, and that we know exactly when a ship is coming into the harbor, when he can into the port, and on the greenest and the most fuel efficient way to get on board. So this is one of the examples what we are trying to achieve. Yeah.
And does everybody know what the Chief Technology Officer does in a company like IBM? I don't. I understand the technology, but maybe you could elaborate on that.
Together we are more or less investigate all kinds of technology directions on a global level, and then we decide what our top 10 or top 20 technology processes and items that we want to invest on. And then we select there 3 or 4, and then we build it out, make product market combinations, and build products and services that we can deliver from the cloud. So for instance, from an AI perspective, we deliver now 50 AI capabilities, from speech to text, text to speech, visual recognition, all from the cloud.
Okay.
Because that is what we are doing. Yeah.
Thank you very much. If I would ask to you as a public if AI will be primarily a threat or a chance in the toekomst, who would say a threat? So 3, 4, 5. Who would say a challenge? No, a chance, I could better say. Okay. If I would ask your mother, if she is alive, if I would ask your mother, and what would your mother say? Is it primarily a chance or a threat? Who would say a threat? Your mother. You don't know? Oh, why doesn't you? Oh, you don't know what your mother would want?
No, my mother would not know what I mean.
Oh, so the challenge is to explain what AI is. She's not here because there are empty chairs. No. So is there something like a generation problem in this technology? Yeah. Could someone reflect on that? Is there a generation problem in this technology, in AI?
If I go to my colleagues who are still driving around in armored vehicles and stuff, and I go like AI, they are like, what are you talking about? So it's not just...
They like to push the big button.
It's not a problem of the younger generations only. It's a much bigger problem, not only for instance, the government, the youngest 11% who are below 35 years. It's a problem of the entire government. So it's not just the younger generation who should fix this. We need some people in the security region to also grasp this subject, I guess.
Yeah, and I think that's very important also to educate people. So what we think it's the best is to combine university and academic relations with businesses and government to build a national AI plan, which is currently in development, to see what kind of priorities do we need for the BV Netherlands. and how can we use AI for our society to make it much safer and more efficient.
What parties are subscribing in this AI plan? Where will that happen?
That will happen by certain groups. So for the Boston Consulting Group is now heading that, and there's all parties involved, from MKB to VNO to all kinds of parties that are part of the ecosystem of the Dutch government.
Okay. Yeah. Okay. Are there already questions now for the members of the panel? Because that's always the interesting part about these public discussions, that the idea is, of course, that there are questions. And I know it's difficult, yeah? Jaya?
I'm just going to take the opportunity to ask. So actually, I really liked Matthijs, what you were saying about the two dilemmas, you know, and I'm thinking about the dilemma specifically in context of the person sitting to your right. And how does that dilemma work out when we know that we have disobedience from human soldiers who would be sent out into a battle-oriented situation, who then could choose, based on an ethical or moral belief, not to execute a particular order. How do we balance these concerns when we are thinking about robotics and AI and drone attacks? Where do we make these kinds of choices apparent and perceptive from a human moral standpoint?
So, and you aimed it at Jelle or Matthijs?
Matthijs,
or both?
Well, I signed this pledge against killer robots for one thing, because I thought in talks I give sometimes, I say I think it would be a good idea if there would be robot soldiers with a sense of ethics, which therefore refuse to execute orders that are harmful to other humans. But of course, the army is not very interested in that. So I think it would be a good thing if people would sometimes make decisions against their orders, because I don't believe every orders that are given by the army are ethically very good. But then of course for the army this is I guess not a very good solution.
Yeah, well, in military law there is a obligation on every soldier to contravene any order which he deems is illegitimate or will cause a war crime. So this is a foundation of military law, he just explained. If an order is really wrong in the Netherlands, then I'm on an obligation to negate that order. So just to make that clear.
Yeah.
And then where this fits in a targeting loop. So we as Army don't authorize lethal violence just at random. We have a very complicated procedure. For instance, in Operation Inherent Resolve, the mission against Daesh, it took very long to get authorization for lethal violence because we want to limit collateral damage, because collateral damage always blows up in our face. So we have very intricate procedures to fit in every aspect there is to a decision, whether it's the legal obligations or collateral damage or ethical ramifications. And we currently are ordering new drones, so we order remote platforms. And this will not change because we have a new platform. Since the existence of the Geneva Conventions, we have upheld wherever possible these conventions, also with new technology. That doesn't change anything there. Even with cyber warfare, we say we uphold international humanitarian law in conflict when we're engaging in cyber warfare. So it doesn't change that much.
Well, although for other countries it did change. If you look at the attacks that are executed, for instance, by the US drone program, there are many extrajudicial killings, I would say, that are against these kind of laws that you just explained. So do you believe that in the Netherlands this could never happen for some reason, because we have better laws than the US, or could you elaborate on that?
Well, we all operate under very similar laws, but the US have a somewhat liberal interpretation of international law. Yeah. Yeah.
But isn't that more of a general characteristic of human beings? I think we are overestimating the judgment capabilities of human beings. If we would make a sort of algorithm and we have a number of rules, you know, what we should do and what not, and they behave like that, then probably we'll behave better than human beings. I mean, if we look at the history of human beings, I don't think that ethics is our core competence, you know, if you see what we have done. So You know,
Okay.
and you can call it a sort of, you can call it the liberal explanation of the laws, but yeah, that's the whole problem with human
I
beings.
think the whole discussion also is affecting Asimov's
More
law.
loud, please.
What?
It's harder.
Oh,
That's the microphone over there.
Yeah.
okay. Yeah? Okay.
Yeah,
So it is against the first law of Asimov, and it said that robots may not injure people. So how are we coping with that? Because that, I think, is a very important one. And also, if we tend to have algorithms that makes decisions without any human intervention, so also from a legal perspective, that is not possible. Because I think that somebody in the war law. I've also joined the army 2 years. There's also something in the juridical sense, and that a private person needs to be responsible for doing the execution, and not a machine.
But now I understood we have machine learning, and Ivo told us that machine learning can go wrong, and maybe will go wrong because of all kind of stuff. Isn't that also possible in military technology?
I think so, because machines can also make mistakes, and that is just as humans.
Any technology.
Yeah, and if you have stupid people combined with very powerful AI, then that's dangerous.
Okay, we have a question, please.
Yes, I think I'm a little bit in favor of robots in military, because if you are walking down somewhere in Vietnam, for example, or in Indonesia in the past, and they capture your body, the guy who's next to you, you find him back later. I can give you kind of examples of what happened, and then those people start killing whole villages. That will not happen anymore because you have the machines in the air, and that's a lot safer for everybody. So I think that the extreme things will not happen anymore. Of course, you will have collateral damage, but the issues that we had in the past will not happen so much anymore.
No feelings of revenge.
Not so much for the countries that have the machines, but if there's a country that has a lot of machines and the other country doesn't have them that much, because you're not sending in your own men, there's a very low threshold to start a war against another country. And I think that's the biggest problem of this, that this threshold to start wars gets lowered. And then, of course, for the country that sends out these drones to kill some people in Pakistan, for the US, it's not so bad. But the Pakistani people, they do get traumatized. And there's also some very interesting documentaries of people becoming afraid for the sounds of these drones because there will be other killings again. Of course, when robots are killing people, it's still affecting people.
Okay, you had a question?
I think the problem is more even complicated than having the robot make a decision or a human having the control. I think even if you take humans far away from the actual scene, pushing on a button is way easier than pulling the trigger. So in that sense, also even taking away decision from the robots and giving it to human, but taking human away from the scene is even, I think it doesn't solve the problem. So we have even bigger problem than having robots or human involvement.
Okay. And yeah, so basically what you're saying, that if the price in human lives is too low for a nation to go into war, the threshold for going into war is too low. So there must be a price into human lives, and not only in technology or in costs. So that's basic.
It also has to be to do with things being equal. So if there would be two countries and they would both attack each other with technology, and there's not then there is not so much a lower threshold because nobody wins.
Okay.
But so I'm not saying the cost should be high, but if there's the stronger countries that are already stronger, they also get stronger by technology, and then it gets very easy for them to attack other countries, then that may lead to bad results.
Okay. Okay. Here's a question. Yeah, come to you in a second. Ja, hier naar voren, sprintje. Just a second. 1, 2. Yeah, there's the microphone. Yay. It's coming down. Over here. Yeah, thank you.
Well, for centuries, the development of technology has always been looked upon with if this is going to be a threat or a benefit for society. The development of AI wouldn't be any different. But what you see is a hammer is still a hammer. You can build a house with it, or you can kill a person with it. It's the same with AI technology. But in the if it is some governments who are having, you know, I don't know how to put it, having bad ideas, then you have technology worldwide having bad intentions. How do we go around it, about it?
I don't know if the question is
Yeah,
well,
how
so
do we
so
deal
you
with
say
it?
technology is neutral,
Yeah.
but it can be used to the benefit and of course to
yeah.
the detriment of a society. And then the question is how you can prevent that.
Yeah, how can we prevent as a whole species to
to be wiped out by robo-killers? Yeah. Is this also part of a discussion within IBM, Gerard? That this technology might also be used to the worst?
Of course, because as a technology provider, we also have collaboration with other competitors as well. So, for instance, we joined the Foundation of AI, where we, together with Apple, with Google, with Microsoft, with Amazon, and 80 other parties are discussing this kind of matters, because also we see that there are difficulties and also societal problems that will continue with these kind of new technology developments. So we have indeed, we have also with our competitors, we have a forum and we have discussions also from applied to fundamental research and also from a legal standpoint as well. So that is indeed something.
And also from an ethical standpoint?
Absolutely. We have also ethical officers in our organization. And we have also bring in trust and transparency in our organizations. And we have also delivering trust and transparency services when we can monitor and when we can decide whether a kind of algorithm, what kind of data models they have used, and also that we can say, you need to retrain that model because that model is biased, and you need to use that data sources to retrain again to make the algorithm unbiased again.
You krijgt een hint.
So, you get a hint.
Yeah. Okay.
So this is an example of what we are doing, yeah.
Okay. So that's partly giving answer to your questions of how to get bias system scrutinized by...
It's called trust and transparency services.
Okay.
And it is also, it can be used for other distributed learning and reinforcement learning algorithms from other parties as well. So from Microsoft and Google and Amazon as well.
And I think this is good news, because if you look at power structures, large tech companies work worldwide and have access to a lot of technology. They're building up a lot of power. Actually, they're getting much more power than current companies. While nation states are limited to the borders of their nation states, and they don't have that power. So the whole power structure is going to change on our planet. Yeah. So what you get is that the relative power of nation states is decreasing and of large tech companies is rising. If companies like IBM and Google and others take that ethical perspective into consideration and they feel responsible for what we're doing in the world, that is good news, because if not, then there would be a big issue.
Yeah.
So I'm very happy with that.
I agree that it is important, but I would add to that large companies, they don't necessarily or don't really have democratic control. So I would say, especially if we agree that companies are getting more powerful compared to nation states, it's important that we demand transparency over artificial intelligence so that we can see how they are making decisions and can explain themselves to humans. But we should also demand some democratic control over it, because we are handing a lot of decisions over to technology, and it shouldn't be just a few powerful companies that decide how these machines make decisions for us. We should decide that together.
Yeah, well, I agree.
I agree.
But
I agree.
Yeah,
as well.
I agree completely. Yeah. But then again, you know, we have to. My opinion is we have to think of different kinds of democracy, and not the kind of democracy we have currently. Yeah. We have to think about. We're talking about world powers, and that is not by voting, you know, for a party or for pirates or something. You know, we have to also innovate the whole democratic system. And one of the things I'm looking for, well, the direction I'm thinking of is that the companies are going to behave themselves as responsible citizens, and citizens are going to behave like responsible citizens. And that's the democratic control I'm thinking of.
That's exactly what happened with the Zuckerberg hearings, right? So the European Union saying to Zuckerberg that he is responsible for social and political stability on his platform. So that's a classical governmental task delegated to the industry. So the first items illustrating this approach are already happening, I guess.
Yeah, but still, you know, the European Union people there are not elected. You know, they're not representing me. And I think there's much more power from people like us, and we take a counter movement. If we don't like Facebook, you know, we move. And we make an app in order to make sure that we are not being captured in a bubble, you know. We do that, not them.
Yeah, we can actually solve this for a part with technology too. There's lots of e-democracy solutions with which people can have a direct say on how companies should develop.
Exactly.
Yeah,
exactly.
And they can develop in co-creation with its users actually.
Yeah. I and Lubach on Sunday would love a solution like this, I guess.
Pardon?
Lubach on Sunday would love a solution like this, I guess.
Yeah, maybe. Yeah.
I guess so.
Yeah,
I
good
guess
idea.
so. We have some other questions. Yeah. We have some other questions. I asked the members of the panel, because we have different roles within our society over here, as I stipulated earlier. We asked them, what would you like to ask another panel member? And Bob, this is your question for Gerard. Well, you can read it, maybe.
I can read it, yeah.
Yeah. Should the Dutch police purchase artificial intelligence security robots? I saw that on the somewhere. That are patrolling neighborhoods that are dangerous. I thought it was Sao Paulo or something.
Yeah, Brazil.
And they're just running there without, you know. And I was thinking, you know, they can collect intelligence, but also if you produce them on a large scale, it's much more cheaper, and you get much more information than if you take police people, and they are also not in danger. So. Yeah. Could be that we replace to begin in dangerous places.
Yeah, it's an interesting question, because you asked that to a son of a police officer. I come from a police family. My uncle is in the police. Everybody in the police except me.
I did my homework.
I did your homework, great. And I think that what I always wanted to be very clear on is that man and machine needs to work together, not separate from each other. So we call that cognitive computing, and we say it is not artificial intelligence, but augmented intelligence. So we want to use machines that support human thinking, that they can understand, reason and learn, and that they will be powered by systems. And relate on this already happens, of course. You said, for instance, the example in Brazil, but for instance in Vancouver in Canada and in the LAPD use also predictive policing in their day-to-day work. So they can already predict where some crimes will exist. And based on all kinds of structured and unstructured data, they can correlate all the data, and they create heat maps, and they work exactly where they can dispatch police officers where they expect within 2 or 3 hours there's something that could be a crime.
Kind of predictive policing.
Exactly. And also they use visual recognition from drones and inboard cars and CCTV cameras. And they can also, using visual recognition, if there is a burglar or a bank robber in the neighborhood of a bank, then they can drive already seen and see and monitor what those guys are doing. And the same system is also being deployed now and piloted in the Netherlands. So it is called the criminal adaptive system, which is almost the same. And then there needs also to be more regulations and more ethical rules how we can use this kind of system, because then you get negative exits such as profiling, etc. And there is no legal authority yet that also monitors and detects what the police are doing. So in retrospective, I said, okay, man and machine together, but I think that must be also an independent authority that also can monitor what the police is doing and how they are using the system. Okay. Is that an answer to your question?
Well, of course, it's a machine-human combination, but that has different kind of, variations, if you know what I mean. So, so if there's at the end there's one person deciding on something, there's also a combination. So we have to decide what kind of combination exactly we want.
Yeah. And we are still in the beginning of artificial intelligence, so that is also, so it needs also development and also what the impact will be on society and what are the real results and how do we retrain those kind of systems to make it more effective as it is already on a day-to-day basis.
Yeah.
Okay. And just to get a flavor from you, who's saying yes? Please raise hands if you say yes, we should buy autonomous systems for patrol. Oh, it's not bad, not much. Okay. So data collecting is okay, and then...
But they use the insights to make it actionable, so that is also the result of having this information available.
And the interesting part in China was that if you crossed the red light 3 times, you couldn't get a scholarship.
Yeah,
so you don't want to go over there.
I don't think we want to have that here in the Netherlands. But that is my
the technical system is the same, I guess.
Yeah.
Okay. Okay.
Almost.
Well, yeah. I would say Siri is already, to a large extent, the same system, but it just doesn't go as far as this system does. Yeah. But I think I'm afraid a bit that we are moving in this direction, and if we are not careful about demanding also the ethics that you are talking about, that it might well happen that we end up with a similar system.
Yeah, but then we need also to have our ideas about, okay, how do we cope with that? So also that means law enforcement, that needs also government rules and regulations. We need also to adapt law, so that it needs also a lot of other modifications in that area.
Exactly.
Yeah.
Now I'm trying to look for this question, but
yeah, it's my question.
That's your question. Yeah, could you elaborate it or introduce it for Matthijs?
Yeah, of course. Just a brief introduction. We're about the same age. We share the same values. Went to the same city, university, and stuff. But he's working for the Pirate Party, and I work at the big, angry, and evil government from his point of view. And
it's better to be a pirate than join the navy.
Yeah, exactly. Yeah. But so the question is, of course, because he successfully campaigned for the Sleepnet wet, or the law on the intelligence and security agencies. He campaigned for that, and in that law there were certain new powers for intelligence and security services. So my question to him, as we are diametrically opposed in this panel as the government and the Pirates Party, which is not entirely true, of course. But how do you strike a balance between the freedoms we both hold dear and the ability of me and my colleagues, some here sitting as well, to do our job?
Yeah, indeed, of course, I also work for the government for part of my time, but yeah. And I'm very happy that you are too, because I think that the government needs smart young people to keep us safe, actually. And for one thing, I think that a balance always seems a bit to suggest that the one thing is opposed to the other thing, but that's not true. It's not like we need to give up freedoms to be more safe. Actually, we need freedoms to be safe, I would suggest. And if you look at this mass surveillance law, we were always very clear that we didn't oppose the complete law. We opposed the dragnet surveillance, as we called it. And also, if you look at the terrorist accidents that there have been in the Netherlands and other countries, then usually the people who made this attack were already known. And I think this demonstrates that the problem is not so much that we don't have enough information. The problem is often, I think, that we have too much information, and therefore we are incapable of acting effectively upon it. So we have always been campaigning for a better law in which there's targeted surveillance instead of dragnet surveillance. So basically only look at the people who are actually a threat. We also campaigned against using 0 days. If there's a vulnerability that's known, then always report it and not keep our devices unsafe on purpose so they can hack us too. Not automatically sharing complete databases, but only sharing certain information from these databases. So we have been campaigning for a better law, and I still hope this law will improve, because I think it is important that this law is updated, but the government should have done way better than they have so far.
I tend to agree, but that's well.
And one thing that I always like to add is that I'm not sure whether you know Bill Binney and his documentary A Good American, but I think he demonstrated quite well that targeted surveillance actually is a lot more effective than dragnet surveillance.
I was on stage with Bill last week, so
yeah, great, yeah.
So you agree on that?
Yeah, but I think this dialogue we're having here in a panel perhaps should be done a lot, well, before the law was even launched, and just to the tech industry or the parties, the government, should have this conversation on what we want to be, what our societies should look like in the 21st century. So with AI or without AI, meaningful human control or not. Because that's also a very interesting issue. The first...
Are we done?
Well, that's one round of applause. Thank you.
No, I completely agree here, because if what we're talking about today and development of different technologies more in general is going to determine the future of us and also the future of our children and grandchildren. If you think what they're doing, what folks are doing in the parliament, they're talking about all kinds of things, you know, dividends and Zwarte Piet and what have you. This is not discussed. I mean, this is where we have politicians to make decisions for our society, and they're not even talking about it.
No, they're lacking the intelligence, or not the intelligence, but they do not have the domain knowledge. The domain knowledge.
But you know, laws are always following the will of a nation. They are not shaping it, they are following it. So where should it be addressed in this discussion, if not in Parliament? Yeah. Should that then be somewhere in public-private partnerships or in think tanks, or where should this discussion then be addressed, if not in Parliament?
Yeah, well, it should be addressed in Parliament. It is not. And I think all kinds of laws are being implemented without, getting people involved. Yeah, so there are all kinds of laws where we have not been, asked what we think about it. There's been not a discussion what kind of society is going to be, not kind of choices that are being made. The whole balance between privacy and security. It's just not discussed. So people make choices for us without informing us and without any discussion.
But we have a prime minister who doesn't like vision.
I think there's no possibility of finding the right way in that sense.
I think there's lots of things that we can improve on democracy to make it easier to get these discussions going, though.
There are some questions, back and over there.
Yeah, we do.
We have to.
Yeah.
And we also have a question from our followers on YouTube. We've talked about ethics a lot, but different cultures have different ethics. So how and who could ever decide on the ethics of AI?
Well, I can explain a little bit about how I developed this ethical decision making for an AI and how what we did with this. So I was mainly interested in medical ethics because that was the focus of my project. So then there were 4 important ethical principles, which are autonomy, beneficence, so making people better, non-maleficence, so not harming people, and justice, which is largely about treating people equally. And then, for instance, you saw that in Eastern cultures, autonomy was relatively less important, and in Western cultures, autonomy was relatively more important. So in Western cultures, people more have a right to harm themselves, you could say. And basically what you then do is just change the weights a bit, because ethics differ on a person, ethics differ per culture, and this way you could simulate all tastes. And then how do you decide what kind of ethics the machine should have? Then I would answer, we need to decide this together in a co-creation. So there's lots of good systems for that, like e-democracy, or going together in a group of experts or a group of civilians together with experts, or civilians without experts, and this should add to each other, these different methods.
Okay. There was a question in the back there, yeah?
Yes, I would like to ask a question also on this topic, actually. Mr. Smith mentioned that there is a foundation on AI, and there are some rules comparable with the former rules of Isaac Asimov, perhaps. but are the activities of that foundation also to be followed through the internet? Are they open and transparent or something like that?
They are
Because
open.
I think that is necessary as discussed in this panel.
Yeah, it is just started last year, so they're ramping up more or less. But I think there's a lot of material is already being searchable on the internet, so you can follow the steps and what we are trying to achieve together. And there are always, from every party, there are also announcements about the information about how we cope with ethics from a global perspective. So you can follow that on the internet. Yeah.
The internet address, please.
Okay, now the Foundation of AI, but I can send it
Foundation of
afterwards.
AI.
Yeah.
Okay, there was a question over there. Yes.
I would like to elaborate on the discussion of the role of the government. I'm missing that role, specifically looking at the fact that only 2 people in The Hague, our national government, do know a little bit about IT and ICT. I'm very worried about the fact that they could play an important role, for instance, by lifting certain regulations or privacy ruling so that corporations can more easily work together and do not need to be very scared for being prosecuted. Because that is what's missing. A lot of people are working on its own, working really together on creating things that would protect us from cybercrime attacks. That will be very helpful. And I don't hear anything about the government,
And
except
who are
for
those
a
2
little
people?
discussion we just had.
Who are those 2 people in The Hague then, who do know about
One,
And
Mr. Verhoeven, the D66 political party,
Okay.
and another, I think, the
I think
CDA.
it's Mona
But it's a
Keizer.
politician.
Mona Keizer from CDA.
Okay.
She is
As members of-
responsible
as
for
members of parliament,
transformation.
There's only 2, and that's about that also account for all the major cities. So if those people do not understand how this world is ruled by technology and what the dangers are attached to that, I'm very scared for the future. So I'd like to see a much stronger rule, and maybe that could also be something for this panel to address this issue.
Okay.
There was
Would someone
also,
would like to react, then I'll
yeah,
come to you,
of
sir.
course, but because we now look at the government like that they have to decide everything, but we just found out that we actually should have a talk about it. It's very classical view also to look at the government in a very traditional way, that they are the sole proprietor of this domain. You just heard Mikko saying that non-state actors increasingly have power and resources. So those non-state actors, whether you are an organization, company, or whatever, you can make your voice heard in the government, which you successfully did. So it's not only looking at the government, because that's a very, very passive role to play, I guess.
It's an ecosystem of actors, but I understand that it is more also a bottom-up approach. There's also from the municipalities and for civilians and companies are now also elaborating on that, and now also the government understands that they had a business reason to act, and that's why also I elaborated a little bit more about that on the national AI plan, and that is coming. So there are some processes, but it is not. It's going not very fast yet, but it needs to be speeding up, because also on a European level, they are also now collaborating and want also to invest billions of dollars of how AI can develop, but also what is the impact on society, also on regulations or law, etc. So it's coming, but I agree with you that we need some additional steps to move this forward into the next merit.
Okay, thank you. Yeah.
Well, to this discussion, I would like to bring an issue of complexity, because I think AI brings complexity to a different level. I mean, algorithms are getting more and more complex, and it seems like even technical giants are losing control of their own algorithms. The data can be only analyzed by AI, and it will get even more worse. So my question is, do we need to start working on AI to control the AI, to make those rational decisions possible? Because it's nice, but I'm thinking, how can you make this decision? How can you even understand how AI develops because of this complexity?
Okay, that's opening the black box then, so to say, in which all those algorithms are.
Well, that's my question. What do we need to do to support those still ability to make those rational decisions, be it decisions about democracy, be it decisions to the extent we should control the development or evolution of AI,
What do we need? Maybe another AI, as I said, to make those decisions possible.
Bob, would you like to?
Yeah, well, in general, for 20,000 years, human beings have been the number one on the planet, right? So we took position on the planet, and then we killed our natural enemies, or we put them into a zoo. So now for some time we are used to be the number one on this planet, but there are limitations on what we humans can do. And what I observe is that we are building a very complex society with a lot of technologies, in which all kinds of things go very fast. So it's going very fast, it's going very complex, and I'm afraid that we are getting to our limits of what we humans can handle as a society. So if we are developing all kinds of complex algorithms, it could well be that it gets out of control.
But so I do agree that we need AI to optimize ethical decision making. Basically, AI often has to do with optimization, and we need to be able to define what is human ethics and then optimize decisions to match our human ethics. And to be able to control this as humans, also an AI needs to be able to explain itself to humans. So that should always be programmed into.
Is that also to your corporate's interest, so to say, to program that additionally in your algorithms?
Yeah, so that you can explain what algorithms do and how what kind of data models and algorithms they are using and how they are going to make a decision. So that kind of things will also be developed and is already developed and is available.
And is that done by the larger corporates? Is that also done by the smaller companies who create AI programs and machine learning?
I do not know what the competition has done. I only know because there's only I think for now, for 3 weeks launched. So it is 3 weeks old, but it is just on the market because there was a compelling reason that we need to have this on the market.
Okay.
So it is also to mitigate a bias for bias systems. And
so
that you can also detect. Yeah.
Okay. Any more questions on this, Ivo?
Yeah, maybe so I of course fully agree with that we should design AI that is explainable and transparent and so on. But it might be interesting to think of context in which it becomes really hard to adhere to these principles. And I think Miko already, I mean, if you have a context of competition or warfare between countries, I mean, you might be much more effective and efficient if you make it not transparent. And in this kind of context, there might be a very strong incentive not to adhere to these principles. So I think the really hard question is not to put up this, I also did myself, to put up these ethical principles, but to think about how can we still adhere to them in context in which actually there's strong incentives not to adhere to them. So maybe that's something, I mean, you can solve.
So we shouldn't wage war with IBM then, probably?
Well, it might be interesting for IBM, but maybe the way they do it now is to agree with their competitors that at some points they don't compete. That could be. Right. But certainly if you think of the context of warfare, I mean, if some other countries are not so willing to adhere to these principles, what are you going to do? I mean,
that's a very point I was starting to form in my head. But if you have AI, the first country in warfighting who cuts out the meaningful human control, is much more faster than the country with human control. So that's the big issue that will arise, because Putin said in 2017, whether he's an enemy or not, you can decide for yourself, but he said whoever becomes the leader in artificial intelligence will become the ruler of the world. Wow, okay. But because warfighting is not about the warfighting itself, it's about decision making. It's about the fastest decision maker has the advantage over their competitor, in our case an adversary. So AI will support this. You see developments in the United States where Centaur configurations, so part machine, part man, are working to better make decisions, better inform decisions, faster decisions. And then if you look at, if we reach a limit of AI with meaningful human control, then the next step is to cut out meaningful human control. And then we have a big issue with all our ethical frameworks on how we're going to solve an actor that doesn't adhere to our ethical standards.
Yeah. So, and therefore I think we should do this with the international treaties. Like we had a non-proliferation treaty on atomic weapons, and there was also a successful case on a moratorium of developing certain lasers that would blind people but not kill them. And then at some point they say, well, this technology is only going to cause a lot of harm for everyone, so we won't develop this any further. And I think we should do the same for autonomous weapons without meaningful human control.
Kind of
Maybe
new
we have
Geneva
to ban all
Convention.
weapons. Maybe that is a better decision.
That's a way better decision.
Well, that would be a good decision too, but that would probably be a bit harder to reach. While this in the United Nations, there's actually quite some support for this idea.
Yeah. But there was also an agreement signed with 3,000 scientists, also with Elon Musk and Wozniak and a couple of others, robotics and AI scientists that signed a treaty in 2015. Mm-hmm. So there is already compelling arguments against. So
although others call them the echo chamber of fear. You know?
Also true.
Yeah. So that's the discussion of the
common sense, important.
So we had a lot of this discussion already. One of the dilemmas brought up, I think it was by you, Matthijs, this one?
That is my dilemma.
Oh, that's yours?
Yeah. Well, the Associated Press account hacked, the Twitter hack in 2013. So the Associated Press account was hacked, and it said, well, bombs in the White House, two guys injured. And the consequence of this tweet was, anybody knows here in the audience? Yeah, exactly, a flash crash on the stock market. So in the weeks leading up to this incident, social media data was coupled to a high-frequency trading algorithm. So when he detected this tweet, it started anticipating a flash crash. So on the one side, you have high-frequency trading, making us lots of money, and on the other side, you have a vulnerability, namely that it can be influenced by a faulty tweet. So it was a dilemma for, I guess, Gerard and Bob.
Yeah. Yeah, please.
Yeah, well, it's a good example because sometimes these algorithms are taking over control of human beings, and they can be manipulated, so something out of control. I think the stock market in itself is being run by computers and not by people anymore. You know, it's a little bit like if you go to an airplane, then there comes a captain of the ship and of that plane, and it comes here with 4 stars and a cap, and then he gets in and put it on autopilot and starts reading a book. And a little bit is also going on the stock market, you know. So the computers are running the show, so that is out of control. The other thing is that I think we should really go to the essence of what society is for. You know, our society is not for economic well-being. You know, the economic well-being is for having a better society. It's not the other way around. And what do we mean by a good society? You know, what makes us a good planet? What makes us good people? When are we going to be happy? Of course, you need something to eat, and you need to have friends and love and friendships and all that. And for that, you need some freedom, and you also need some security. More of one is less of the other. And we need to make some kind of context in which we focus on the things that really matter. And economic well-being, and you know, these are all, these are means to get to that end. And I think we should have the discussion what do we really want as human beings, given those new technologies, and what is really important, what we should put on the priority.
Okay. Gerard?
No, I have no...
Famous last words on this one?
No, let me
because
say
we are wrapping up the discussion.
We are wrapping up because it is... so the trust and transparency is very important.
You already elaborated
but I've elaborated on that.
Matthijs, any thoughts on this one?
The trust, transparency and democracy.
Democracy and transparency. And responsible citizenship. I think that also was a very nice phrase.
Nice.
Any last remarks from people in the room? Yes, please.
Well, kind of going back to that, what is a good society, good decision for society? As, for example, we have now, let's say, those automatic tellers at supermarkets, which replace 20 tellers to now just one checking all the machines. And obviously, for now, it's good because those people are going to do other jobs, but at some point, there's not going to be the balance anymore, and there's not going to be things for people to do. So is there something you also think about? Because I hear about the AI when it's a strong AI, but even now as an AI, I'm guessing it's going to be an issue for people. Is there something also you guys discuss while having these discussions?
No,
This last question.
AI will impact jobs, but there is a report of the World Economic Forum, and they have investigated that 75 million jobs will be lost, but there will be at 133. So the net is more than that we are losing jobs. So it will change, and that's have everything to do with technology development, what we saw in the early days and early centuries with the new industry roadmaps. You see the same results. So. But I agreeing on that we need to see what we need to do. So things about basisbeurs and all kinds of other things, we need to digest that and see what we can make a decision on.
Okay. Well,
yeah,
thank you very
I
much.
actually think this is a great opportunity for us to think about what we are doing, whether it's really meaningful. So I would say that robots can work for our basic income and give us the cognitive space to actually think about what we want to do with our lives in a meaningful way. And we should change our education system, not to prepare us for a job, but to prepare us for giving meaning to our lives.
Well, I think that's a very nice way to close, to wrap up this meeting. Thank you. Can I have a warm hand for the panel, please? Thank you very much.
So guys, it is a bit of we've gone over time, so I've been trying to coach Thijs, who's completely off script, to kind of keep to time. So, so I was like, time. But I want to thank you. I want to thank you all for being here for this session where we just scratched the surface of this subject. And what I'd like to see you take home, if we've done anything, we've brought Jelle and Matthijs closer to a bromance. So, always good, right? And I tried to clap to support your bromancy statement. So we'd like to see more of that. And what I'd like to ask you to do is to think about the takeaways from this. I think we need to learn not to fear AI, but to look for the opportunities here and responsibilities that we have in order to make sure that we have some form of the good stuff that's in our society, not the bad biases, but the good stuff, because the biases we're gonna get them free of charge. So if we make sure that the morality, the ethics that we hold so dear are there and ensured when we introduce AI to different ways that we are gonna employ it, whether it's warfare or the teller or whatever, that we have that. I think we also discussed that we want a Geneva Convention-like mechanism so that we have, also we didn't discuss it, but the Talon Manual might also be a point of reference because we don't have that, and we do see collateral damage on non-military targets when it comes to cyber stuff. So I think we need to find a better balance and not just reside or depend on the Geneva Convention. And then the third thing is, I think we need a very strong sense of community. The community like the bromance, but a community of informed and educated people who are willing to do things together to actually figure out how to solve the problem from a multidisciplinary approach. So I encourage you to take part in the dialogue and to realize that you have an intrinsic responsibility by just being alive in this time that we're all alive in, to do something with this dilemma and to get the fruits of it for all of us. So I would like to invite you for the network drinks now, so we can actually start building this community. I'd like to ask you to please return your badges. I can tell you they were really expensive, and I need to conserve on that budget that we started talking about in the beginning of the day, so I need you to return those badges. And I want to thank you, everybody, Bob, Jelle, Matthijs, Gerard, Thijs, Ibo. Where's Miko? I miss Miko. Oh, no, there he's right. Oh, okay. All right, so Miko, I thought I saw phantom sighting. Okay, so I'd like to thank all of you for being there, and the people who are attending online, thank you so much for a successful online event. Thank you.